Hey, we got 9. We got a few more minutes. So I guess we didn't. So did you ask Rodney if he thought we needed a meeting last Friday?
You know what? I didn't. I forgot. I didn't talk to him about it. But I think you're right. Like we should just do it maybe to do a wrap up, as sort of like if we need to discuss anything at the end.
Yeah.
So, that would be good. I'll send an email and see when everyone's not Val, just us, right? Just me, you, and
Yeah.
Rodney, or.
And let's see. What do I have something Friday. I have something.
Yeah, I can't do it.
Oh, let's.
Go ahead.
Well, you're talking about Friday, right?
Yeah, but I can't do it this Friday afternoon.
Oh, okay.
So maybe we could do it either I don't know, maybe morning or maybe on Monday, or I don't know what you think. Or maybe we could do it Thursday afternoon sometime.
Yeah, let's talk to Rodney. I can do it Thursday afternoon, and then Friday morning up till 11. I have something at 11. So.
Okay.
And
all right, I'll send an email and see.
Yeah. Probably we should do it before next week. I don't know how how the administration's gonna wrap this up.
Yeah.
Because it's an unusual class.
Hi, Luis. Good morning.
Good morning.
How are you?
Hanging in there. How are you guys?
Good.
Pretty good.
Thanks.
Good.
We're hanging in there too.
Yeah, I think so. I think that I saw an email that some of the students have the option of doing some work next week, like I don't know, working on some professional development hours, and then they can get paid for next week as well. So
yeah, oh, that's good.
Even though we're not continuing this morning class, they can still do some work for that last week.
Yeah,
so that's good.
Yeah, no, that is good.
That's for next week.
Yeah.
Yeah, I think there was an email that maybe one of the instructors sent, might have been Val or someone else, that you can opt to sign in for like an hour counseling session or something for next week. If you sign in for some hours, either Monday, Tuesday, or Wednesday next week in the morning, you can get paid. You can get a check for next week as well. So check your email.
Cool. Thank you.
You're welcome. Check your email, because I think I saw it maybe on Thursday or Friday last week, an email that went out about that. So I would take advantage if I were you guys. You're available.
Monica, did you take geometry? You took geometry in school, right?
Ooh, yeah, I think so. Maybe like sophomore year of high school. Sure. Is that what we're working on today?
Yeah. Yep.
I really liked geometry actually. So we'll see if I remember anything today. Did anybody else? Do you remember taking geometry?
Nice, yeah.
Yeah. Kind of as a mathematician, I feel like he did. Hi, Jasmine. Good morning.
Good morning, everyone.
Good morning.
How was your weekend, Monica?
Yeah, good. We've been going down to, that parking lot across from Ledbetter where the people like skate and stuff on the weekends. Has anybody seen that? There's a City College parking lot at the bottom of West Campus that's really flat, and people like skate on the weekends out there. So we've been going. I bought my daughter some roller skates, and then we have a skateboard. So we've been going and just like riding around.
Oh, that's great.
Yeah. So we did that on Saturday. We did that last Saturday too.
Are you a skateboarder?
No, I'm just doing it for fun and like to get my kids outside, and they have like
Yeah.
all kinds of like scooters and bikes and skateboards, and then they
Yeah.
just ditch everything and they just start running. So they just like run laps and stuff and sprints. They like doing like, let's race. So I've been
Yeah.
doing that.
That's a great thing about little kids is the energy just drives them, you know?
Yeah, they don't want to go anywhere. Like they complain for an hour about having to get in the car and go somewhere, and then they get there and they're like, yeah, and they're, like real wild.
Yeah. Yeah.
Yeah.
That,
What about you?
that energy is so beautiful. It's hard to deal with at times, but you know, from a distance, you can really, especially when you get older and you start losing that energy, you go, wow, it's so great.
What about you? Did you have a nice weekend?
Yeah, some friends that I haven't seen for a while, we went on a walk. You know that open space hike around UCSB and Devereaux Slough. There's all those fields are open where the golf course used to be there.
Uh-huh.
So we walked
I
from
think
there
so.
to the beach and then back along the slough.
It's nice.
The beach was really exciting. The surf was pretty good, was getting bigger and offshore. So the waves were really good. And there were a lot of really good surfers out there. It was really fun.
Cool. Nice. So is it close to Campus Point, like where everybody goes to surf right there?
Yeah. But you know, usually they're between Campus Point and Coal Oil Point and IV, but I guess the swell was a little different and they were to the right of Coal Oil Point, you know, where the plover, is that the name of the bird? The plover reserve is there.
Mm.
It was a little different place, but yeah, it was crazy.
Isn't it the snowy flower?
What's that, Gerardo?
It's snowy flower thing.
Yeah.
Yeah, the bird. Yeah, I think that's what it's called.
Yeah, they're protected there. And there's dunes right there. It's really interesting. It's funny how parts of the coast have a lot of dunes, like what's up north? All you Santa Maria guys, the dunes in
Beach.
Guadalupe.
Oh yeah.
Yeah.
Usually Oceano dunes.
What's that?
Oceano dunes are a lot bigger and you have access to like quads and stuff like that.
Yeah, yeah, yeah. I got to get up there more. It's beautiful, beautiful walking up there. Well, you know, I ride my bike a lot, you know, for exercise, but walking's a whole new different set of muscles. I went on about a 10-mile hike on the beach the other day with a friend. You know, we just kept going and oh man, was I sore. And I thought, why am I sore? I work, you know, I ride the bike, but different muscles.
Well, if you're walking on the beach, like that's another whole set of different muscles.
Yeah, right.
Because, well, it depends on whether the sand has moisture or not.
Yeah,
Because when there's less moisture, it's even like way harder because you're sinking in
right.
and there isn't
Yeah.
any firmness.
Yeah, I know. I got to be careful. Well, it just means I have to do more work.
Have you ever done kayaking?
Yeah,
Yeah, I tried it, but I got seasick over the weekend.
yeah. Oh, that's great. Out in the ocean?
Yeah,
Yeah,
Wait, did you throw up? Did you vomit?
I was about to, but as soon as I was in, like there was a swell, so I just had to get
Yeah.
out.
yeah, yeah. It
So,
was, yeah. I used to live in Maine and I used to canoe a lot, which is a little bit like kayaking in the lakes. That's fun. That's fun stuff. Kayaking's fun. They rent kayaks still everywhere, right?
yeah, I believe so.
Yeah. I used
I don't
to,
know. Did you guys see a while back? I think it was over by Avila. There was a lady kayaking and that humpback whale came up. It was on the news. I don't know if you guys saw that.
did it upset her kayak or just next to her?
No, it looked like it was gonna swallow her. but it ended up, yeah, she just ended up falling. There's a video on YouTube.
But she turned out okay.
Yeah,
Woo.
yeah, it's so crazy.
That would be scary.
That's what's scary. Yeah,
Yeah. Well, sharks sometimes bite at kayaks too, right?
yeah, I'm sure.
Get that paddle ready, you know. And you know, it's funny. Everybody from elementary school up should be taught how to deal with sharks and that, you know, like you can hit them on the nose and, you know, freak them out. So it's little facts like that that could save your life, you know. Most of the time you think, oh, you know, that's it. I'm just helpless here. Well, okay, getting there. How was the water temperature, Luis?
Cold, like usual.
Yeah, I know. I wish global warming would at least warm up the ocean water for us.
I think in Mexico it does a little bit.
Yeah, even if you go down south, LA's warmer, noticeably warmer, and San Diego's a lot warmer.
Yeah.
And then of course Baja and down, it's warm. That's what's tempting about living in Hawaii, is just having that warm water all year. Monica, you ever been to Hawaii?
Yeah, when we were kids, like growing up, my parents used to take us in the summer.
Yeah.
They're book teachers, so they would be like, okay,
Right.
teachers, we're on vacation, let's take our kids to Hawaii every summer. But not as an adult, I haven't, no.
Yeah.
Not yet.
I've always been stopped over there on flights, but then we finally took our kids when they graduated from high school, and they didn't have that much fun, but I liked it.
Yeah, my parents love, like that's like their favorite place to go on vacation. They like to go to Maui, like, and like my dad doesn't really like going places, so it's like the farthest he'll go, really. So
Yeah. Right.
my mom likes to travel, but my dad doesn't, so
Yeah.
that's as far as he'll go.
You know, it's funny. I mean, the kids of teachers have whole different outlooks on life, you know, because my parents got a really cheap home out in Palm Springs, but because they had summers off, we'd go out there in the summer, which is the wrong time to go because it's boiling.
Yeah. Oh my gosh.
But you know, that's teachers. All right, I guess we can get started. Yeah.
9:15.
So we're gonna do geometry all of today, and then I don't know how far we'll get, and I can't remember. I mean, I haven't figured out what we're gonna do tomorrow. I'll talk to Monica about what would make a good last day. I mean, I'm prepared to wrap up the math and just kind of do loose ends and practice it, but we'll see if that makes sense. I mean, it is a math class, I guess, but we've taken a little liberty with all these classes. I mean, a 3-day trade math class is kind of crazy anyway, but. Sam, great. Okay, so before class, I asked Monica and several of you if you'd ever had geometry in school. So is there anybody in this class that has never taken a class in geometry? Jakub.
Geometry or algebra?
Geometry.
Yes.
So Jakub's had probably the most different education, seems how where he grew up. So when did you take geometry? Do you remember?
When I was in high school in India and here too in SBCC, not SBCC, the Week Center.
Yeah, but in high school in India, I wonder if their curriculum is probably close to ours in some
Yes.
ways.
Yeah.
Yeah, because it's probably British influence, and ours is a little
Yes.
bit that way too. So, does anybody remember their geometry classes? What they did in them? I don't remember anything about any of my high school classes. It was such a great impression on me. I've forgotten every single thing.
That's where it's like degrees and angles, right?
Yeah, did you kind of fool around with figures, squares and angles and?
Yeah, I remember like acute angles, obtuse angles, stuff like
Yeah,
that.
okay, great. Anybody do something, anything different than that? You know, for years, and this may just apply to me because I'm older, but when I took it in high school, we used Euclid's geometry. Euclid, this ancient Greek guy, wrote a book, and they used it till today. It's pretty amazing. But it had geometrical proofs was a lot of it. So they would prove theorems. And we spent most of the class proving these theorems, which is more logic than math. And it's a weird way to teach geometry, is by these formal logical proofs. And it's kind of like a game. You can get into it, but you know, geometry is such a great thing to apply to life. It's a shame not to talk more about squares and circles and, you know, areas and volumes and stuff. So anyway, did anybody not like geometry and do poorly in it? Would anybody admit that they did poorly in a class?
I didn't do
Yes.
that well. I can't I can't even remember the theorem, the
Yeah,
Pythagorean.
right.
We never
Pythagorean.
use that shit.
Yeah. Well, good. Then this will be good. Today will be really great for people. So in the trades, you know, we've been dealing with arithmetic like the last time because you got to use a tape measure and measure things. So that's really important. But geometry is also important in the trades. And more than that, I think geometry is important in life. I just think people should know the basic things. The great thing about life these days is you have the internet and you have your cell phones. And if you need a geometric, you know, formula or some kind of information, you can get it pretty instantly. So you don't need to commit all this stuff to memory. But if we go over it, at least then when you want to access it, you'll have some idea of what you're looking for. So the Greeks started, like Francisco mentioned, Pythagorean theorem, which is named after a guy named Pythagoras. And he lived in, I don't know, 500 BC in Greece. And, you know, most of the time we attribute things to these guys. There was a whole school that followed Pythagoras. So we don't know who came up. In fact, they even think the Pythagorean theorem was invented by the Mesopotamians before the Greeks. But the Greeks were a funny kind of people, the ancient Greeks. They were a warrior culture, but they also had slaves. So in the ancient days, if people had wars and they won, they would take all the able-bodied men and make slaves out of them, bring them home. And so it wasn't slavery like the United States where we just went to one place and got Africans and brought them over, but it could be anybody you had war with. So the Greeks had slaves, and you know, they would bring them back to Greece and they would just keep them in their homes. They would be like servants and things. And sometimes they were even freed eventually. But because they had a slave culture, the wealthier people didn't have to work at all. And if they were intellectual at all, they would sit around and discuss philosophy. They would have dinner parties and they drink wine and discuss philosophy. And a slave culture is never a good idea. It's a bad way to treat fellow human beings. But nevertheless, because of that, we have the geometry we have, because they sat around and they would just think about geometry with all their spare time. That's how it came about. It probably would have come about eventually anyway. So when you learn it in school, besides the proofs, which we won't do, you know, they go with Euclid, and his book starts with lines and then areas and volumes. And we're going to do something like lines. We're going to do perimeter, which is the outline of something. Because in building, a lot of times you need to know the length of a perimeter of a house. You have to order boards for it. So taking perimeter with squarish shapes like rectangles and squares, and for circles. Sometimes you need the perimeter of a circle, which we call a circumference. So we're going to look into that today. And then beyond perimeters and line type things, we're going to talk about areas, because that's another really important thing in construction. When you order materials and make estimates for what you need, you have to know geometry to figure out the material you need. And then also volumes. You need to know volumes sometimes too. So it's pretty straightforward. And a lot of these formulas, as we go over them, you'll remember them for sure. So I've got a slideshow, and these slides are also in your Canvas files in case you want to look at them. And then I've got some worksheets afterwards, and we'll just do a few problems from them. But if you guys get excited about doing the geometry and either want to do it for fun, does anybody ever do problems for fun anymore? Or if you just want to practice and get a little better at it, you can hit the files, in the days between the classes. Okay, so we want. Okay, does everybody see this first sheet?
Yes.
Thank you.
It's blurry though.
Okay. Yeah, it's so weird. I can enlarge it. It's so weird. Sometimes the enlarge, you press the plus sign and it gives you a scale, and you have to pull up the scale. Today it's just enlarging each time I hit the plus. It's all what's the word? Surprise. It's all surprises. Okay, to find the perimeter, there's the word that we've been using, perimeter. Hey, Monica.
Yeah.
So a lot of words in math are from Greek. So in Spanish, do they keep a good part of the Greek spelling?
I think so. That's
So
a good question. I think.
Yeah, does
I
anybody
don't
know
know
it?
this.
Does anybody know
Spanish
the
is
word?
probably derived from Latin, not Greek.
Okay.
That's also in a Spanish word.
Perímetro.
Okay, perimetro. Okay. Okay, great. Yeah, I would think a lot of these words will have the similar root. So
Similar, yeah.
So we're just in these perimeters, just the distance around these. So if they give you a figure like this, and then they give the different lengths of each side, you just add those up. So that's pretty straightforward, right? And see this word polygon?
Yep.
So poly means many and gon means side. So a many-sided figure is a polygon. And that usually assumes it's a closed figure. So there's no opening in it. All the sides meet. So a polygon just means, if you say it means many-sided. So this is a four-sided polygon. And then we have names for certain of the polygons. If they're at right angles, so each of these is 90 degrees, then we call that a rectangle. And a square is actually a type of rectangle. It's a rectangle that has even sides, but we give it a special name because we use it a little more often. So you probably know those words. And then these all have right angles in them, but then you can have a polygon with odd angles too. That might be a right angle, I don't know. So it says find the perimeter of each one. So these are pretty easy. On a square, if they're all the same, you can just multiply any one side by 4. like here. So that would obviously be 4 times 6 or 24, right?
I think perimeter is mostly associated with side by side, side plus side plus side plus side, and then area is multiplication.
Yeah, except for area of a circle. Then we have a special formula for that. And triangle, we'll get into those, but yeah. Yeah, area will be multiplication and perimeter will be addition. Good point. So perimeter is pretty straightforward. I mean, you just add. However, there's a few tips. So look at this number, this first one in the third row, row 3 here. It's like an L-shaped or a step shape. Notice I wrote in the 3 here, but when this was given, it just didn't have any length for these two sides here. So if
That's
you have to find the perimeter, obviously you need to know those. So I filled them in. I wish I hadn't, but I mean, I wish I had erased them, but so if they didn't give these, how would you find out what lengths these sides were? Pretend these written in 3s aren't here.
By taking into account the longest length and the longest width.
Yeah, so in other words, if say we want to do this one, you take this longest length and do what?
Well, you take into consideration the 3 inches that is labeled, and it's 3 out of 6, and then the remainder
Right.
3.
Right, so you take this and subtract a 3 from it and you get this, good. And you do the same, it's exactly the same for that, for the horizontal side here. So sometimes in a problem, even if you're doing a sketch on a job and you want to, you know, that's the shape of the floor you're going to cover with tile, or that's the shape of the building and you need to know the amount of plywood for the floor. You're going to have to find this dimension to do the area also here. So you'll often have to, we call it interpolate, or just find something that's missing from the stuff you already have. Excuse me. The other tip is when you're solving these on a test or just by yourself, the best way is to make sure you fill in these, because you can be looking at this and go, oh, well, I know those are 3. And then start to add it up and then forget to add those because they're not showing. You should just start going to the numbers and you go 6 and 6 is 12 and 3 is 15 and 3 is 18 and stop. And you won't include those. So always fill those in, even if you know what they are or they're obvious. Just so when you start counting, you'll have all numbers to count. You see what I'm saying there? Yes?
Yes.
Okay.
Yeah.
So same with over here. If you'll notice, these are filled in too. So when they gave this figure, they just put it's a rectangle. So they just put the 2 sides that are different. So that's when you're going to do area, that's fine because you just multiply those. But if you're going to do perimeter, then you have to make sure you add these other 2 sides. So always transfer the 8 to that side and the 12 to that side, and make sure all sides have numbers next to them. That way, when you go to add perimeter, you don't get fooled. Okay, that's pretty simple. Now we're going to skip area for a second on these and go to circumference, because circumference is the perimeter of a circle. It just has a special name. So circum is a root, or it's maybe not a root. It could be an adjective side of the word, but circum means around. It comes from circle. And anybody hear of a word that's got circum in it besides circumference?
Circumcised?
Circumcised? Yeah.
Braver
Great
man than me,
example.
Luis.
Great example. So you're cutting around the penis, circumcised, good. And circumnavigate, a plane will circumnavigate the globe. It'll mean flying around the globe. So yeah, good words, good, good one. Okay, so circumference is just another word for the perimeter of a circle. And this page kind of shows, and the ancient Greeks, the ones who started geometry, they didn't know about, they thought all numbers all the best numbers. They actually gave qualities and status to numbers. I mean, these were people that were beginning to deal with numbers and counting and operations. And so they thought, oh, wow, this is great. The universe is very orderly and there's all these whole numbers that we can work with. And then they came across numbers that weren't whole numbers, and that really freaked them out. You know, they could do a half, something like that, but they couldn't do decimals. They just didn't know what decimals were. So, but they could see relationships in a circle. So they could see that the diameter.
Isn't a decimal abstract concept?
Yeah, it is. That's why they didn't get to it. I forget when decimals came in. It was pretty late, probably medieval times, if even that. Yeah, it's very abstract as things go. Good observation. But they realized that if you took a string this length and you fitted it around a circle, you'd realize it goes 3 times with a little bit left over. So they said, well, okay, so the circumference is a little more than 3 times the diameter. And in fact, we know now that it's 3.14 times, or 22/7 is close to it.
Oh, pi.
Or pi, we call it pi now. And the Greeks call it pi too, but they didn't have decimals, so they didn't have they may have used 22/7, I'm not sure, but they didn't have a decimal value for pi. So, you know, how would you express it? They could express it 22/7, and I think the Mesopotamians before them may have discovered this and used it. You know, they're approximations. So for most work the Greeks had to do, probably that this was a close enough approximation. So that's what actually pi is. It's the relationship of the diameter over the circumference. I mean, the circumference over the diameter. If you left pi on this side of this equation and put the diameter on this side, divided both sides by d, you get pi equals circumference over diameter. So pi is a ratio of these two lengths. And so when we want to find that ratio in terms of numbers, we have to we go into decimals. So for circumference, for a formula, it equals pi times d diameter, which is distance across the center of the circle. Or an alternate formula is 2 pi r, because 2r equals d. So a radius is just from the circle out. So a radius is obviously half of the diameter. So you can express it this way, and there's reasons why they express it 2 ways. Partly is sometimes you're given the radius, and so you don't have to double it to get the diameter. You can just use that formula there. So whenever you see an R, it means radius. Whenever you see a D, it means diameter. And the diameter is equal to twice the radius. Okay, so those are things we know. And this formula for area we'll look at in a minute. So again, if we're wanting to find circumference, when a math teacher gives you a problem like this, they have to give you a value for pi, because every student may use a different value and the answer will come different. So if the teacher wants a uniform answer or wants to be able to tell if the student did it right, they have to specify which value for pi. Now, remember when we talked about decimals, we talked about repeating decimals. So pi actually goes on forever. It never stops. It never goes to 0. You know, we used to learn 3.1416. We used to sort of memorize 2 more digits, but it just goes on forever. So, so if a teacher wants a specific answer, they have to give an exact value for pi. So in this problem, they're saying use 3.14 for pi. That's close enough. Sometimes in my classes, I use just 3. So it'd be easier to It's not as accurate, but it'll be easier to do the math work.
Hey, Patrick,
Yes, sir.
what's the holiest meal?
The holiest meal? I don't know what.
Pie, because it's eternal.
Did you just make that up or did you hear that?
No, I just made that up.
Are you kidding? That is great. Well, that's great. That's one of the first times I've heard a math joke created spontaneously. Way to go. Oh boy. You know, the holy meals are a big deal. So I was trying to think, what's that one that's coming up? The Last Supper? Or
I was trying to keep it relevant to the.
I know, it's great. I love it. Okay, I'll use that again. Can I use that? Do I have your
Absolutely.
permission? Okay, great. So to solve this problem here, it gives us a 3-inch radius for the circle, and we know pi, they gave us a value for pi. So we just multiply 2, we use this formula here because it's given in radius. So we go 2 times pi times the radius, and that comes out to be that. And that's our answer. The circumference all the way around the circle is almost 19 inches. Now here they give a different, they're going to use area, but they give pi as 22/7. But it's an area problem. We'll do that in a second. So I think that's pretty straightforward, right? And you may not remember these later in life because if you don't use them, you're going to forget them. But they're really easy to find if you just look up on the internet, geometrical equations or like circumference of circle, and it'll go right to these formulas. So here's a circular platform. So this is an application in building, has a diameter of 20 feet. What is the area of the platform? Well, we won't do that now. Let's see if there's a perimeter one. Oh, here we go. No, these are both area problems. We'll do those in a second.
What's
So we've
the
got
term for the water line in a tube? Is it meniscus or? Because if I recall right, in a cylinder.
if you have a tube and if you have a tube vertically and the water's up to the top, how it goes up a little, the pressure pushes it up a little bit, so there's a little round curve of water. Isn't that what you're talking about?
Yeah.
Yeah, I think it's meniscus or something like that. I don't really know. It's a scientific term more than a mathematical term. So it's something like that. Okay, so how are we doing? Okay, this isn't taxing you too much, right? Okay, so perimeter, and we'll do a sample of problems involving perimeter later. Let's just kind of go through all the basic ideas here first. So formulas are also used to find the area or the measure of the space inside a flat figure. Area is measured in square units. So perimeter is always in linear units. So that's a word we should write down, linear. I'll write it on the board and show it to you in a minute. Now it comes from line, right? Linear and line. It has line in it. So what's line in Spanish? L-I-N-E? Is that
Linear.
what's
Linea, yeah, linea, it's the same.
Recta.
so linear, that's an adjective. That's kind of a specialized term. I don't know if anybody would know it. It means line.
Gerardo said maybe recta.
Yeah.
Línea recta.
Okay, great. So perimeter and circumference of circle, those are distances. So they would be linear measurements like feet, meters, inches. Now we're getting into a square areas. So they're measured in square units, square feet, square meters, that kind of thing. So each of these shapes has its own little formula. Square is easy. It's just the side times itself. So I don't know if we talked about this yet, but when you see a little superscript, they're called, it's a little script, a number above. You have subscripts for chemistry, and then you have superscripts for math. So S, and we say squared, or S to the second power, just means S times S. So if this is 3 squared, it's just 3 times 3, or 9. So probably a lot of you remember that, but just in case you didn't. So you don't have to say S. You could say for area S times S, which would be just as simple. But they're trying to introduce a few more terms here. And a rectangle is the same way. Here you can't do S times S because you have different length sides. So you do so the area is length times width. Everybody's pretty familiar with that. Parallelogram is this kind of square that's been sort of pushed over. So it's still got horizontal top and bottom, but the sides are now at an angle. And you can I never remember this formula. It's actually the same formula, but I never remember it. So when I go to find this area, I always just cut this I make this dot, and it's like it shows you if you move this triangle over to this area, then it becomes the same rectangle like this, with the base the same amount and the height the same. But in a parallelogram, the height is not the length of the side like this. In other words, the length of this side is not the same as the height. That's the one catch in this. So they have to give you the height, this measurement here, they have to provide that for you. They may give you the perimeter, they may give you the distance of the bottom and top, and they may even give you the side distance, but it won't help you with the area unless you have this distance from top to bottom here. And then in a triangle, so let me go back, parallelogram. So the easiest way, instead of trying to remember that it's the same actually as base times height, it's not really the same as this because a side's different than the height, but it's similar. The best way is when you see it, say, oh yeah, I remember, we can just take this triangle and put it over here and do that, and then you'll know what dimensions you need to multiply. So triangles, one that we use in building more often. And so this is the formula is 1/2 base times height. So the base, if the triangle is put on the paper like this, the base is this bottom part, and the height is from the base at right angles to the apex, to this corner here. So if the triangle's like this and it's not a right triangle, well, this could be 90 degrees, but this triangle is not a right triangle, then you have to rely on someone giving you this height here in order to do the area. And the way to remember, a lot of times, if I can't remember formulas, I'll just look at there's certain classic shapes of these things that you can, like we did here, you can kind of figure out the formula by just fooling around with the areas, shifting them. And here, this is a different kind of triangle. Well, it actually is this triangle, but no, it's not, it's different. But if you take a square and you draw a diagonal, you're cutting that square in half, right? The area of this side is going to be equal to the area of this side. But what is the area of the whole square? Well, we know that it's side times side, so it's this times this. So the area for half the square, or this triangle, would be 1/2 the bottom times the side. So that's where we get that. So if you can't remember that formula, draw it out and say, well, a square is base times height. So a triangle, which would be half of that, would be half of base times height. It's harder to visualize when they draw the triangle like this and it doesn't have a right angle. But if you do a square and divide it, you can easily see how to find the area of a triangle. Does everybody understand that?
Yep.
Okay.
Yeah.
You can always memorize this. I don't have a good memory for numbers, but I have a good visual sense. So I always go to some kind of figure and draw it out just to make sure. Okay. So sometimes you get a triangle that looks like this down here in the first row. And that is the height. They have to give the height actually outside the triangle because of the way it's shaped. So they would have to give you this 4 feet. Or if you're, if you've got this triangle, you're trying to make this triangle at the site, job site, you may be able to draw this out and just measure this distance here. But in a problem, they have to give you the height, and then the bases you can see. So then you can get the area of this triangle by the same formula, 1/2 base times height. So it's 1/2 6 times the height 4. So you get 12 for that area, just that triangle in there. They put this dotted line because that's not really part of the triangle area. It's just the way they figured it's showing you what how the altitude or height, sometimes they call this altitude, is H, height or altitude. Here's a problem, and I did the same thing. I showed you how you can sort of lop that off and put it over there. Can you solve this problem here? This is a
Yes.
parallelogram. So what's the formula for a parallelogram? Area?
Base times height.
Base times height. Do we have a base? We could take 10 as the base. Do we have a height though? What's this 7 inches? Is that a height?
No.
No, because the heights have to be perpendicular, right? Anytime you have a height, it's always perpendicular to the base. So this one, they try to fool you. So this one, they give you a side, but if you look closely, this side is less than 90 degrees, less than a right angle. So it is a parallelogram, but they don't give you the height, so you can't solve this. Every once in a while, this book will try to fool you. Haha. So these are just area problems. These are easy. Let's save the problems till we get into the more trade problems. Now here's an addition to this, a variation to this. These have been just single figures, triangles, squares, rectangles, parallelograms. But sometimes you'll have to add complex figures. So this isn't really a square, but you can see it as a combination of 2 rectangles. So this is really important in building because you often get combinations of shapes, and you have to be able to break down those shapes into individual figures that you can find the area of. So this one didn't have this line. It's just a office and storage, but you can make this line, parallel to this, a continuation of this side. And then you'll have 2 rectangles and you'll have all the numbers you need. So for this one, we can, remember I said, make sure you transfer the numbers so you count them up. For area of this rectangle, you don't really need to do that because you can just multiply 10 times 20. But if someone said find the perimeter, then you'd want to take this 10 down and put that there, and also take this 10 down and put it here so that you know this whole thing's 20. Otherwise, there's no way you'd know this is 20. You know, you have to add these two together. So here you can do 8 times 10 for an area, and you can do 10 times 20 for an area. Add those together. So we'll look at more figures that are compound figures in a second. So here's one where we have a rectangle and a triangle together, right? So I drew that line in it. That line's not really there. They just give you this figure, which really doesn't have a name. But you can see, can't all of you see that you could easily just draw a line across here and make this a triangle by itself and a rectangle by itself, yeah? Does everybody see
Yeah.
that?
Yeah.
So if we want to do the area, if we want to do the perimeter of this, does anybody know if we could do the perimeter of this? Do we have enough information here? In other words, to find the perimeter?
I think you're missing
Yeah.
side.
We're missing this length here, right?
Yeah.
So Francisco brought up the theorem, the formula, Pythagorean theorem, and that theorem allows you to find this side if you know this side and this side, and it's a right triangle. This is a square angle here, 90 degree. So we're going to look at that formula in a few minutes, but you could, with these two information, find this length, and then you'd have the whole, then you could add them all up. But in terms of area, which is the problem here, if we separated that into a triangle and a rectangle, how would we find the area of each of these? Anybody?
You multiply the sides, right?
Well, for which one? Which figure?
For the triangle.
For the triangle, so what's the formula for area of a triangle?
Would it be pi? Oh, no. I mean, I'm not sure. What did you just do?
Well, you know, just go up, if the answers are all here, like if I ask for an area formula, you can just go back up to this area. And so here's triangle, just to refresh, because, you know, we're not memorizing these yet. So 1/2 base times height, right? Is that right? That's the formula for the area of a triangle.
Mhm.
So so this is a right triangle. So what would the base be? You could take either of these as a base, right? You could
6.
stand it up and have it the tall side up, or you could have it squat. So 6. So base is 6 and height is 4, right? So 6 times 4 is 24. And then the formula is 1/2 base times height, or 1/2 24, right? So that's how we'd find that. And then obviously this one is just 6 times 9, this rectangle. And then you add those together. So does everybody see how that's done?
Yep.
Now, this is a compound figure. It's composed of 2 or more separate figures. If you drew a line up here, a lot of times you continue a line that's already started. But if you continued this one, it would give you this rectangle here, which we know the dimensions of. But then you still have this trapezoid or whatever this is called here, which we can't solve. So you eventually still have to cut off this triangle. So when you come to one of these, you can experiment. You can draw a line here and say, well, maybe this is it. And then you go, oh no, that still leaves us with a figure that we have to break down more. And then you can either leave that and figure all 3, or you can erase that and extend the line this way for these 2 figures. Okay, what about this one in the center now? If they want to know the area in black, can we find that?
Yeah, you can.
So how would you do it?
You multiply the sides again.
So that would give you the area of this whole square, right? 100, 10 times 10.
Mhm.
But that didn't include this area. I said just the area of the black. So we have to subtract this inside area, yeah? But can we find the area, this inside area? Given the information we're given?
It looks like it could be half of that, like a
It
5 and
looks
5.
like that, but we can't really go by looks because it could be slightly. So you're right. If we were just doing a course, if this wasn't important and it was a little off, we could take half of that and make this, well, it'd be a third of this, right? If this is 10, if these are each the same width, that'd be a third of that 10. So
2.5.
yeah, third of 10 is 3.3, about 3333. And then we'd multiply it by itself to get, I don't know. If this was a third, here's a problem. If this was a third, like you're assuming it is, I'm not sure it is, but, and in a math problem, if a teacher asked you to solve it, you would say, I can't solve it with the information given, because in math, you shouldn't use a visual, because things aren't often drawn to scale. So, and sometimes you're asked to solve problems without rulers. You know, these are just all problems that can be solved without actually measuring anything. So, but say this was a third. Somehow you established this was a third of the way across. Then this would be 10 over 3, right? This length here, because it'd be a third of 10, yeah?
Mm-hmm.
So if you're going to multiply this by itself, then you've got 10 over 3 times 10 over 3, right?
Mm-hmm.
So you get 100 over 9. Then you don't need to break it into a decimal yet. Okay. So everybody that's still awake and paying attention, raise your hand. Oh, I can't see it because I'm on my thing. So so Monica can see though, right?
Yeah, I can see a couple hands up. Yeah, most.
Just a couple?
Well, some people are physically putting their hand up and some people are raising their hand in the box. But yeah, most everybody's here.
It's easier to hit what is it, a thumbs up?
No, it's you can raise your hand if you go to reactions, or what's it called? Raise
Yeah,
hand.
yeah.
And click on.
So people find it easier to go there and hit that than to raise their hand on the screen.
Because if they're not showing their face right now, then it's easier to just raise your hand.
Oh, Lord. Okay. So back to the work, kids, people. You're not all kids. So say we wanted to do the perimeter of this cross, Greek cross. How would we do it?
You add up all the sides.
Yeah, but a lot of the sides, how many different length sides are there? I mean, how many different lengths for a side are there? How many, 2, did you say?
12.
No, but I mean, how many, what lengths of sides are there? In all of this?
It looks like 8s and 5s.
8s and 5s, yeah. So we've only got 2 lengths here, good. So we could just add up all the sides and then multiply, right? When you add consecutively, that's what multiplication is, making that easier. Instead of adding 2 numbers 5 times, you can multiply the numbers by 5. So we could just count all the 5s, but in order to do that, we have to make sure each side's labeled, right? So that's 5, that's 5. So it looks like they're all labeled. So then we just count 5. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 5s. So 8 times 5 is 40. And then we have 1, 2, 3, 4 8s, right? So 4 times 8 is 32, 40 and 32, 72. So it's easier to multiply. You could say, okay, 5 plus 5 is 10, plus 5 is 15, plus 5 is, and then your sister comes in and asks you where you hid the Pepsi, and then you lose track and you've got to start over and count. So counting has its dangers. If you space out, you can't remember where you are. So that's why multiplication is kind of good here, because I can go 1, 2, 3, 4, 5, 6, 7, 8 before I'm interrupted, and I can multiply that by 5. But you'll ultimately have to do it your own way. Now, what about area for this figure? So these lines weren't here. You can see they're kind of squiggly. I added these middle lines. And again, I shouldn't have done it because this gives you such a huge hint. So who wants to tackle finding the area here? Let's have one person volunteer. Geez, people don't even have their audio turned on.
Everybody's nervous.
It's so quiet. Volunteers.
So
Are
it
we
might
doing
be
the
like
area or the perimeter?
Area.
Area.
No,
Okay, I can do it.
don't. I want you to walk us through the problem, not just give me an answer.
Oh, all right.
So who's volunteering? I need a name. I can't see you because
Francisco.
okay. I knew it was his voice. I just wanted him to say it. I want you guys to be aware that I can't see you right now. When I have a screen, when I share the screen, I don't get pictures. The gallery view.
To do the area, I would, let's just say on the left-hand side where it says 8 centimeters. We're gonna start there and we're gonna add the top 5 centimeters and the bottom 5 centimeters to make that 18 total centimeters.
No, you're doing perimeter though.
Oh, I thought we were doing area. Okay. In
That's a
that
good
same
point.
event,
Though.
in that same event.
Wait. Let's go back to perimeter. I think you're on a good idea. You're saying do one of these boxes, 5 and 5 and 8 is 18, and then multiply them by the number of boxes.
So the boxes are intersecting, correct?
Well, yeah, but I'm saying if you're doing perimeter, just go back
Okay.
to the perimeter because you started that, and I think you had a good idea. You were going to take one box and figure what the perimeter was, and then multiply it by the number of boxes.
Yeah, well, the 5. Okay, you know what? Let me try doing this on my tablet because I was able to hijack Rodney's screen.
Well, okay. Well, I mean, let's just we can just walk through this. So Francisco's a pattern seeker. So he's always looking for order. I'm guessing, Francisco. Okay.
Yeah.
Don't get upset if it's
pretty
wrong.
accurate.
But from my observation of Francisco, he's always looking for order and patterns, which is a great skill. Everybody should have that. In fact, all of you have it, but you don't, maybe not are conscious of it, and maybe you don't use it as much as Francisco. And also I wouldn't know because he's the only one who talks.
Can I give it a shot?
Yeah, hold on. I'll give you the shot for the area, okay? But let me just finish with the perimeter here. It's good to seek patterns, shortcuts, because one, they're faster, and two, sometimes they're more comprehensive. They allow for less mistakes along the way. In math, that's always important. So if you can see that each of these three sides on the box on one side is the same all the way around, and that exhausts the perimeter. In other words, the perimeter is all made up of, it's made up of 4 boxes that have these 3 dimensions. Then you're really home free. Then you just go 5 and 5 is 10 and 8 is 18 times 4. And you get 72, which is what we got before. So that's really a quick way to do it. So you got to make sure that the pattern you're seeing is correct. But Francisco is right on the verge of doing it that way, which is an alternate way of doing it, and it's a good way. So who said they wanted to take a crack at the area?
Me, Luis.
Luis, great, go ahead.
All right, well, the area would be 8 times 5 for one of the boxes, correct?
Yes,
So it looks like there's 4 boxes that look the same. So that would be 40 times 4.
yes,
And then that gives you the length of those boxes.
the area of those boxes, right.
And then, but we still need the area for that middle box,
Yes,
which is 8 times 8
yes, excellent.
times 2,
No,
right? To
There's
get the
just
whole
one-
area. Oh, okay.
yeah, just one center box, so. Who's doing that?
That's me.
That's great. So, yeah, so 8 times 8, 64, and
Oh, I did that
Yeah.
wrong.
yeah, and 160, we said?
Well, the other ones were,
Well, that's 8 times.
Yeah, 4 times 40.
yeah, 4 times 40.
Yeah, 160 and then 80 is 240.
Yeah.
But I'm less concerned with the answer, which you got right, as the method you did it. So that's great. So Luis saw that there are 4 boxes that are, and this is similar to the perimeter problem because we realized that each of these 4 appendages were the same. So he just took the area of one of these and multiplied it by 4. So that was smart. And then it left him, he still had that middle area. And of course, we know the dimension of that because it's the same as the 8 here. So that's why these lines across here really help for the area. It'd really be hard to do with area without it. So yeah, so 160. So right. So that's pretty simple. That's a way to go, Luis. Now there's another way to do it that students have.
No.
No, it was 140 and 64.
Oh, you're right.
No, 160. You're right. I'm sorry. You're right. You're right. 224. So each of these is 40 times 4 is 160 and then 64. Yeah. Okay. Okay, great. So that area for that. Now, the other way is this. Pretend this is a box that goes from along here, the biggest dimensions, right? Pretend that's a square that you want to find the area of. So that would be 5 and 5 and 8. That would be 18, right? So 18 times 18 would be the area of this whole thing. So whatever that is. And then what you're going to do is subtract these 4 little boxes from that, and that'll give you the area of the cross. So little boxes are 5 times 5, or 25 times 4 is 100. So 18 times 18 minus 100 should be 224. Who wants to brave 18 times 18? Oh, look, I got a calculator right here. You guys can see me, right? Oh, how lucky can you be? So
Yes,
that's
324.
324, and we said this was 100, right?
Yeah, minus 100.
324 and 100 is, no, minus, thank you, minus. You're right. 324 minus 100 is 224, bingo. Same, should be the same answer. Or we're in deep poo-poo. Okay, so with these combination shapes, if they're symmetrical, this is radially symmetrical, then you can really use your pattern skills and make quick work of it. When it's like this, it's less easy because these are weird kind of shapes. But so while we're on a roll, let's do these 2 here. And then we'll take a break. The square carpet in a room 15 feet long on each side covers all but a 2-foot border on each side of the room. What is the total area of the carpet? Now this problem really requires drawing it out careful. So along with doing the math, I'm trying to give you guys problem solving tips, which many of you already have. So I'm not telling some of you anything new, but there's probably a few of you that they'll be helpful too. And drawing things out is really helpful, like this one especially. So you have a square carpet 15 by 15. So that's the box, the outside box. And then it looks like they might have drawn it in, so that's good. But you need to, if they hadn't, you need to draw the inner box in, because they're saying the carpet covers all but a 2-foot border on each side. That's the important point, on each side. So it's not just 15 minus 2 feet, because it's 2 feet on the left side and 2 feet on the right side. So that means there's 4 foot of floor in that 15 feet. So that means it's 15 minus 11. So the carpet itself will only be 11. Everybody see that? So when you're finding an area that's part of an area, make sure the part you're subtracting is, if it's a symmetrical, same distance on each side, then make sure you count both sides. It's easy just to subtract 2 from 15 here if you're doing it in your head. Yeah?
Actually,
Yep.
that's
Yep.
kind of complicated, or I'm still trying to wrap my head around it.
Oh, good. So yeah, so it is worth thinking about. Yeah, we know the total size of the room. So also word problems are not always stated entirely accurately. So look at this one, the square carpet in a room 15 feet long. So that's actually literally correct, but it could easily be seen as the carpet is 15 feet. Right? But it's saying the square carpet in a room of 15 feet. So that's easy to misread. So, but they actually, if you look at the picture that they drew while you're reading the problem, then you'll get it. Say, oh, 15 is the total side. Oh yeah, it's the room. Okay. And then it's 2 feet in on each side. So 2 feet, 2 feet, 2 feet, 2 feet. And I would, they don't put a number there. So I would go ahead and write the 2 feet in that space on each side to help me visualize.
It's tripping me out because for some reason I want to think that the carpet is 13 feet.
Yeah, exactly. Okay, good. So
Because yeah, you
well,
want to take away 2 from the 15, but
Yeah,
it
yeah.
doesn't pan out.
the border
Right.
is only 2 feet.
So I've taught this class a number of years, so I know the typical problems students sometimes have. And that's really a typical one. That's why I want to go over it. So in word problems, word problems are actually pretty hard because sometimes they're not worded totally correctly. They don't have the commas in the right place. They're not grammarians who write these. And sometimes they're just very complicated. So if this didn't have a picture, you would be really smart to draw this yourself and follow what they do and make sure that the picture corresponds to the words here. Monica, are you drawing something?
Yeah, I was gonna drop myself because it doesn't, to me, I'm doing the same thing in my head. It doesn't make sense seeing it like that. So
Yeah,
now I'm looking back up at the drawing up here of the 10-inch by 10-inch square and thinking, okay, that's the carpet, the white part in the middle. Like imagine that was the carpet.
Exactly.
So the reason I think it's confusing everybody is because we're subtracting 2 from 15, right? But
Yeah.
we're not taking into consideration that it's a square basically inside of a square. So that means that there's 2 feet on every single side, equidistant, right? Like this is 2 feet,
Right.
this is 2 feet, this is 2 feet.
Hey, Monica, how are you drawing that?
It's called annotate. So when you go to the top of your screen, there should be an option to annotate.
Annotate.
It gives you a bar. Yeah.
Yeah.
And you get a bar. So then you can draw,
Oh,
or
okay.
you can put like.
Okay, thank you. I haven't been drawing because, oh, wait, what do you put? How do you do a straight line?
draw, and then there's an option to make the squares or rectangles with the third one in, draw, and then click the third
Oh.
square.
That one there?
You see that? And then you can do arrows, like if I want to say, okay, this part here, this.
Wait.
distance here is-
Somehow I got lost here. So the annotate, oh, there it is. Somehow I didn't track. Okay. Fourth one is draw, and then you do a rectangle, right?
Mhm. So basically, like, this is 2 feet, but it's also 2 feet over here. So you have to subtract 4 from 15, right? So if
Right.
this is all 15, you need to subtract 2 on this side and 2 on this side. Same thing with here. Sorry, it's not a square. I did a rectangle, but I meant to do a square.
Okay. Wait. Get out of eraser.
This right here is really cool because I stumbled across it just messing around with my stylus last Thursday, and I was just doing swirls on Rodney's screen. But yeah, being able to contribute, I guess, with a pen or stylus.
Yeah, that's great. So, yeah, I just didn't, I only
You gotta
learned
fool
what
around with it.
I only
Yeah,
learned
play
what I
with it
need
a
to
little.
learn. So that's
Yeah.
great. Thank you. So yeah, so that is a good problem. That's why I chose it. Let me get out of here.
Wouldn't it be 15 times 15 and then that would give you the total area?
So the
But-
same way we did this problem up here, you can do this one here, but it's not as practical. You can always,
Well, the other ones, well,
Yeah, these-
documented.
yeah, these problems all have a couple ways to solve them, and sometimes it's more practical. Like this one, it's funny because I have students that say, oh, I would much rather do the total and subtract the little bits. And it's just the way they perceive things. They have a particular skill where they can take the whole and take parts away. I'm more additive. I much prefer to add parts. But I've learned over the years that it's a difference in people have. So to subtract these, you'd have to go 2 times 15 times 4. So 2 times 15 is 30. You have to subtract 120 from 15 times 15, 225. Or something, I don't know. It's easier just to say, okay, this is 15, the total length, and I'm subtracting 2 from each side. So 2 and 2 is 4. 4 from 15 is 11. So the inner box is going to be 11 on a side. And then I can square that for the area of that carpet. So 11 times 11 is 121.
Wait, how'd you get 11?
So this was 15.
Uh-huh.
And then these were 2 on each side. So 2 and 2 is 4. So this is 4, this length here is 4 minus this length here. And this was 15. So 15 minus 4 is 11. So the inner square is 11 on a side. This should be a square.
11 here?
That's so funny that this problem's causing because you guys have solved much more difficult problems.
It's easier how Monica drew it. It makes sense now because you can tell that that's just the border now. I thought I was in my head I was seeing it as 2 feet like for the side.
Yeah, if you look at this drawing closely, I admit it's scribbled, but it's got 2 feet on each side there over the space area, and then the rug's colored in. So it was there. It was just harder to see. This is easier to see. But here, when you draw these, this is what I've been telling you all along. Make sure you put 2. Can I put? Does annotate have numbers in it somewhere? Does text have numbers? No.
I think you could put numbers down in text.
Monica, where'd you get the 2?
Yeah, click on text, so the second one, and then just type in 2. What do you want me to write, 2 again, or?
Yeah, write 2 in each
On
of the
each
4
one?
areas.
Yeah, so.
But wait,
this-
where do you,
this
where do you, I'm on text and I'm not,
Click on text and then click where you want to draw write the number and then just put a 2, should come up. So all of these are 2 feet, basically.
yeah, but it's
you see
not
it?
working, it's not working with text.
Huh. You make sure that you click before you start text, before you start typing.
Yeah, I
Make
click,
sure you
I click
where you
text
wanna
and I click text and nothing happens.
But you also have to click where you want the text to go.
put the cursor and then now click like a space or do. There, now, go ahead. Now just write something on the keyboard.
Well, yeah, I did. Oh, two, it didn't take first. Okay.
Now it
Okay.
should, now.
Okay,
click- there
got
go.
you. Okay. Okay, thank you. So, yeah, so like I've been telling you all along, to fill out all the areas that you need and don't just do one side and think, oh, it stands for the other side, because you'll forget it, just like you forgot it originally. So put 2 on each side, and then if you put 15 across here, then you'd know that this is 2 plus 2, 15 minus 2 plus 2. So it's 15 minus 4. And that's 11. So each of these inner circles is 11.
Would since it's 2 foot on the outside perimeter of the inner box,
Yeah,
and we're only trying to take into account the area,
it asks for the total area of the carpet,
of the
inner
inside
box.
carpet or the borderline carpet.
No, this is floor here. Oh, no. Francisco. So, okay, this is great. Okay, here's an assumption you have to make that I've been making and Francisco hasn't been. The square carpet in a room 15 foot long on each side covers all but 2 foot border. So that means the border's the floor underneath, the wood. You could think about the 15-foot carpet with a different color carpet on the outside, a border, because carpets have borders.
Mhm.
So that is very confusing. So there's an assumption that I was making and some of you weren't. But I think the words bear me out. But that's why you got to be really super careful. So the square carpet in a room 15 by 15 long. So we know the room's 15 by 15 at least. On each side covers all but a 2 foot border. That means the border is non-carpet. So only this inner box is carpet. The border they're talking about is the border of floor that shows. Does everybody see that?
Yeah.
It is confusing. That's why we're doing it. And that's why word problems are only as good as they're written. If they're confusing.
If you were to rearrange the border, it would still, if you condensed it into a square, it would still read like 2 by 2, right? Or
No, this area here is 2 foot across, and this outside area here is 2 foot across. And this is whatever the difference between those two together minus 15.
well, it would be like 2 feet width by 15 feet length, except for it would run short on these sides.
Well,
because
she's
of the-
drawing a rectangle, which is a little maybe confusing, but
Yeah, sorry, I meant to draw a square.
but
Well,
it's
that's
symmetrical.
2
So
by
whatever
15,
you
right? And then another 2 by 15 on the
No.
bottom.
well, yeah, but see that's if you're taking the whole 15 and you're going to subtract these outside areas, that's
And
what you
then
wanted
this-
to do originally. That's harder. You can do it that way, and you're doing it the right way. You have to subtract those, but that's a lot of work when you can just subtract the 2 and 2 or 4 from 15, which is 11, and you get 11 both ways. Then it's just
But-
11 times 11.
If we're just figuring the area, the
Of the carpet.
of the carpet or of the
No, the
2 foot
carpet.
border? Oh, just, okay,
Yeah.
I've been trying to figure out the border.
Okay, so the question that they put, this is all preparation. Then they say, what is the total area of the carpet? So I thought you were trying to find the area of the carpet by subtracting all these borders from the room, which is a way to do it. It's just more work.
But after figuring out the border, you'd be able to take that from the total area of 15 by 15. And then that would give you the difference, right?
If you subtracted the sum of all these borders from 15 times 15, yeah, then you'd have the carpet area.
Okay.
You want to do that?
I think it's a good way to do it, but then also you want to find the shortest operation to get the answer. I mean, it's a good way to check your answer, right? If you want to go back
Sure.
and check, but
Sure.
I think in math, if you're going to do it, what's the most efficient way to do it?
Yeah.
With the least amount of operations.
Right.
I mean, I get it, Francisco, it makes sense, but you're doing more operations to get the same answer.
So let's
Right.
make sure it's the same. So 2 times 15 is 30, and another one down here is 60. And then you're subtracting 4 from,
That's 11 and 11, so it's
11.
22.
So that's 121 and 60. 181. Yeah, we're getting fouled up.
44. That's 44 by 60. That's 104, isn't it?
So 60, and these are 11 by 2. Oh, these are 11 by 2.
Yeah,
20.
which would be 22.
Yeah, so 44 plus 60, 104. Yeah. So 104 is the border, and 15 times 15 is 225. So 225 minus 104 should be 121 with any luck. Yeah, so we get the same answer. But one thing Monica didn't mention was one of the reasons one of the definitions of simple in math is least vulnerable to errors. So the simplest way that we did it first has less capability of error. Adding up all these, there's just that many more chances of error, and you're doing more operations. So, so you want to do the operation that's the simplest, both conceptually and in terms of least errors capable.
So
Yeah.
what's the simplest process what's the equation for figuring that out?
Area, total area minus, no. Well, there's not a super general formula, but if I were going to make a formula for this, I would say total length minus,
Because the only numbers we're given are 15 and 2.
yeah, total length, which is 15, minus 2 times border. So that's 2 times 2 is 4. But in a formula, I would do total length minus minus double border squared.
Double border square. So that's 4 squares, so 16?
No, by border, I meant just one side. So,
Okay.
so, so total side length minus 2 times border width. And then a whole thing in parentheses squared. But see, that formula is so unique to this situation that's why they don't make that's why they don't make those kind of general formulas. There's too many unique situations. It's more like rather than a formula, it's more like a type of problem. So you have problems where you have negative and positive areas that you're working with. It's more of a certain type of problem. You know, this could be that same type of problem. You've got shapes that are negative and positive shapes, and you're trying to get just the positives. So let's just do this one. You guys are really engaged. This number 3, a triangular flower bed is divided into 4 equal sections. So this is the flower bed. This is exactly what it looks like. And they want to know what is the area of each section. So is anybody looking at this problem?
Yeah. Isn't it base time height by half?
Yes. But listen, they're asking for they tell you about all this combination, but then the question is, what is the area of each section? So all this rest of it is irrelevant. You only really need the dimensions of one triangle. So if it's 7 by 7, what's half of if it's 7 height and 7 base, what's half of the base times height?
24.5?
Yeah, because it's 7 times 7 is 49.
Oh,
And
shit,
half of
the
that
answer's
is
there.
24 and a half. Yeah. So, yeah. So, so word problems, and this is a real problem if you're a second language student, which many of you are, or even bilingual. Bilingual means you learn 2 languages growing up, but one could be much more dominant than the other, right?
Yeah.
Monica would know this because this is her profession. But Monica, if a person's totally efficient in both languages, is that ever possible?
Yeah, I think so, to be equally fluent in 2 languages. Yes, if
So
you were born with 2 languages at home.
Yeah. So you would just
Well,
say,
a lot of Europeans got like French and German.
oh, I know
or-
Europeans are ridiculous. They have 2 or 3
Like if you're
languages
from
fluent.
Switzerland or something.
Yeah. Yeah, they're crazy over there. But so yeah, so part of word problems is understanding the English in a fairly deep, nuanced way. So if your English wasn't really as good as a native person, you might have a lot of difficulty with these. And maybe, I mean, that's something maybe we could talk about during our breakout thing. Monica could talk about. I don't know if there's a solution to this. The one thing that's important for everybody is to read through it, to get the general lay, and then find the actual question, because that will determine whether you use all this or whatever. And so what is the area of each section? So, hey, they're only wanting that. And whether you're bilingual or not, you can say, well, I can certainly find the area of this because I know the height and sides and the formula. So making sure you grasp the question is really important. That'll help anybody, whether your English is not, the same as a native speaker or not. Okay, I'm sure your brains are probably busting out of your skulls. Let's take a break. Math takes a lot of thought. I could go on all day. I love this stuff, but we'll do some after. Let's take a 10-minute break till maybe quarter of. No, wait, that's not 10 minutes. Maybe 10 of. Monica,
So
is that good?
10:50, come back at 10:50.
10:50, yeah.
Okay, yeah, that's
Okay.
perfect.
All right. See you guys in a bit.
Thanks.
Oh.
I think having trouble with reading the slides. I didn't bring my reading glasses, but it's okay. Just listening and just taking into account the measurements, and that's very interesting. Thank you.
Sure. Are you pretty good in geometry?
I'm just refreshing the long time ago that
Yeah.
I haven't done it. Yeah,
Of course.
okay.
Yeah. That's true
I've
for
been
all of us.
looking in internet, try to refresh it more easily, the internet with examples and everything like that.
Hmm.
Because that'd be good. Because if I go into construction,
Hmm.
yeah, fine.
We got a minute by my clock. Okay. Ready for some more? So here's a problem that was this number 4 here. A circular fountain has a diameter of 12 feet. A 2-foot wide path surrounds the fountain. What is the total area of the fountain and the path around it? So it's similar. We have to draw 2 concentric circles. Monica,
Yeah, yes.
you want to see if you can draw 2 circles?
Sure, yeah. So you got to annotate again up at the top. The third one over says draw,
Yeah.
and then you can draw a circle. So first circle is, did you say 12 feet? Is that big enough? Oh, there you go.
Oh, I got an oval somehow. Oh yeah, look at,
Okay, pretty good. Well, you can also do you can do on the inside. Oh, it has a path around it, a 2-foot wide path surrounds the fountain.
yeah, so they're concentric. The centers of the circle should be on each other. That's interesting. It doesn't really go to a circle. It goes anywhere you want it to go, right?
Yeah, you can make a circle like an oval, you can make it longer.
How do you make it bigger?
That's a pretty good circle right there. You just did.
Yeah, but I want to. How do you draw? Can you draw a concentric circle? That's wild.
You might want to delete that one and try another one off to the side.
Yeah, let's start over.
Well, they have to be inside each other.
Well, but you have to figure out your point of reference of where you're starting and what that develops into.
Okay.
So, okay, I can try it. So we need one and then another one with a 2-foot circle inside of it.
Well, yeah.
So then this is it's 12 feet and then this one is, oh, it's hard. Start again.
How'd you draw that first one?
You just gotta start in the corner and then pull, drag it.
No, but it turned out a circle. You didn't have to.
No, I just tried to drag it kind of straight.
You
Okay.
could probably draw another one and then place that one on top of it, because I saw that when you come over it, it provides options when your cursor's over the green line.
So Monica,
Let's see what I can do.
oh, bingo.
Is that it?
Yeah.
Okay. That's hard. It's
So
not exact.
how'd you do that?
I started from a corner I started in the top left corner and just pulled down to try to make it an even circle. Because if you try to think of it like starting in the middle of the circle, it doesn't do a circle, it does an oval. So you got to think of a corner and then pull.
But I didn't see you work at all. It just appeared on my screen.
Oh yeah, it doesn't until I commit to it, it won't show up. I have to practice.
I see. Okay. Okay, great. So you want to put 2 foot on each side?
Sure. So this is 2 feet in between 2 feet.
Yeah, isn't that what it
And
is? 2
then-
feet? Yeah. And then put it on this side too.
Okay.
I guess this could also be seen as like a tire in the rim, right?
Yeah, sure.
Although like
Okay.
a 15-inch would probably be a donut.
And then
And
if
then
you
the diameter is
12
feet.
foot, 12 foot in the inner circle.
Okay. So in here, it's 12.
Okay, excellent. So we're assuming these are, diameters along a diameter.
Do you want me to draw a line for the diameter across the middle circle
Well,
or no?
you could draw it all the way across the whole, well, if they're concentric, draw it across the outside circle.
Okay. So go to draw again. There's the second one is like a line. So
Yeah,
you want to go.
just
you
a
wanna
line
start-
from left to right. It might
One-
interfere with the numbers, but who cares?
Okay.
Oh yeah, perfect. That's close enough. Beautiful. Um, So according to the problem, a circular fountain has a diameter of 12 feet. That's from there to there. That's the fountain in here. A 2-foot wide path surrounds the fountain. That's this path here. What is the total area of the fountain and the path around it? So
All I remember is pi.
Pi times diameter.
Just
pi r,
involves
Pi times
pi r
12.
squared. Pi r squared, right? Hey,
what is r?
Monica,
The radius, so half the
you
diameter, right?
want to attempt to do a pi r squared on there underneath that?
Oh, I don't know.
Well,
Let's see if I can find the symbol. Might be able to do it.
Oh yeah, I think it's a challenge you're well prepared for.
The
Okay.
diameter, wouldn't that be like
I think it comes to 48 plus 16 equals to 64.
All right, well, let's
I think
check
so.
that out. So we're doing the pi r squared, so we need the radius. Pi will take as 3.14, let's say, like here.
Pierre,
Oh, there's the formula right there.
Pierre al cuadrado en español.
And then radius, so this is why I wanted you to put the 2 feet on both sides. Because we want to find this whole diameter here, and then we're going to find half of it for the radius, for the r. So if you just put the 2, you would tend to add 2 plus 12, and that would be 14, and that wouldn't be the diameter of the whole outside of the whole area, right?
no. Well, we're trying to figure out the radius, which is wait, the radius is the full length across, right?
No,
And
the
then
diameter is. So we're going to find the diameter first and then cut it in half for the radius, because the radius is what we need.
14.
Yeah, but that's because you're adding, the path goes around the whole circle. So it's really 12 feet across the circle, and then it's 2 feet on each side of the circle. This is the same as that carpet problem, except it's a circle.
I wrote down here 12 feet plus 2 is
Yes.
16.
So that's diameter. If you can do a diameter equals, if not, don't worry about it. And then r equals half of that 8. So,
Okay.
so Francisco, do you see that the distance across the diameter of the inner circle is 12 feet?
Yeah.
But then to get the diameter across the whole thing, you need to add the 2 on each side.
Yeah. I see the necessity. For
Yeah,
that.
that's why I had her draw it that way. But it's the same confusion as in the square problem. I mean, it's an easy mistake to make. That's why you should always draw it. If you just did this, you would probably do 2 and 12 is 14. I think anybody would. That's why it's really critical to draw these out to get your bearing. And then, so Gerardo, is that what you got for a? Oh yeah, you got 48 something. So you well, let's see. So for this formula for area, that's for area. What is total area? Okay. So we want r squared. So r is 8 feet. So we're going to square that or times itself, right? So that's 64. Is that right?
Mm.
And then 64 times, say 3.14. Let's use that value. Let's see,
200.
64 times 3.14.
296.96.
Yeah, 200.96. That's what I get. Oh, that's what we get here.
I wonder if there's a correlation.
No, but okay, so that's good. I mean, so, you know, we can follow the area formula pretty easily, but it's set in a word problem, it's setting up the problem that's critical. You know, that's why they're a step beyond just applying the formula. When they had the figures and they said find the area, that was just perfunctory. We could do that with our eyes closed. But these take a little bit of consideration. So that's good. You guys are getting this. Okay, so let's go now to volume. We've done perimeter, we've done area. Get rid of that. And we go to volume, yeah? What's volume in Spanish?
Volumen?
Volumen.
Okay, great. Great. Well,
Spelled
that
the same
helps.
way, just pronounced differently.
Yeah, well, that it helps that these are all Latin languages, you know, makes it simpler. Okay, so volume's 3 dimensions. Area was 2, length times width, kind of on a flat surface. You know that in geometry, when we're dealing with area, there's no such thing as a flat rectangle or a flat triangle in the real world, because everything has 3 dimensions in the real world, everything. So there's no such thing as just an area by itself. It's always, that's an abstraction. We're separating it from the solid 3rd dimension that everything actually has in the real world. So
What about
geometry's-
paper?
Well, paper's still got a thickness. It might be mill thick, but it's still going to have a thickness. But we treat it like it's flat because we don't want to deal with that 3rd dimension. We just want to know the surface area. So we're actually making an abstraction. Geometry is an abstraction that way. It looks like the real world, but it's, you know, if you start talking about areas, there's really just only volumes, but we can talk about it any way we want. And it's simpler to talk about it as areas and then adding the 3rd dimension for volume. So what's a cube in terms of shape? What shapes are involved in a cube?
Right angles?
Well, right
Square.
angles. What's this shape here?
Squares and
Square.
rectangles.
Yeah, so cubes, right angles and squares are right angles, and it's how many? 6 sides? So so 6 squares together make a cube. And a cube is just like a square is really a member of the rectangle family. A cube's really a member of the rectangular solid family. So we can take any shape, like a rectangle, which is an area shape, and when we want to make a volume out of it, we call it a rectangular solid because now it's a solid piece of reality. So we could say a circular solid is a cylinder. So we can make different solids, but we often have specific names for them, like cube, cylinder, and these are the ones we mostly do in construction. Sometimes we'll deal with volume that's what's the word? It's liquid volume or fluid volume, like concrete. Concrete's not really, doesn't have any shape, right? It takes the shape of its container. So, but we still can get a volume for it. But
Is it fluid ounces and then dry ounces?
no, we don't go there. Those are fluid things, but we don't use those to measure cement or concrete. I was just saying we use volume for those, but they don't take their own shape. These particular figures might be things on the job. This might be a piece of 4x4 beam. This might be a pillar or a pilaster in the ground. I mean, a caisson in the ground. Because these figures hold their, wood holds its own length. But dirt and cement, you just get a pile and it just expands until it kind of is stopped by something, gravity or the walls. So we deal with those 2 kinds of materials, ones that hold their own shape and ones that don't. But anyway, let's start with these that hold their shape, and then we'll do some problems that involve volumes of dirt and concrete. So, volumes like area for the rectangular things, it's just length, it's just the 3 dimensions, however many dimensions. Area you have 2, so it's length times width. Volume you have 3, so it's length times width times height. And you'll notice that rectangular solids, these names are variable depending on how the figure is situated on the ground. So if it's a building, so a skyscraper, so this would be standing on end, the height would be this side, and the width and length would be, the dimensions on the ground. So these, and sometimes we say, instead of length, we might say depth. This is the width, this is the height, and this is the depth, how far it recedes. So beware that the three dimensions in rectangular solids have variable names. They're kind of relative terms. Yeah?
Yeah.
Okay, and we'll see that demonstrated. And then a cylinder, so this is really important to look at this as a square, as an area, which is length times width, the first two, times a length or a height, because we're going to see that that's that comes in handy to look at volume as area times one other dimension. In a cylinder, it's area, a circle, times the length of that piece. So we do the area, which is pi r squared, and then we have height or length times that. So we'll do some problems with these.
Will we cover displacement?
No. You interested in that? I mean, this
It-
stuff goes on
it
and
kind
on,
of
right?
Runs into it to some
Yeah.
degree.
Yeah. So let's see. So let's just look at this problem right here. So they're saying you use 3.14 as pi, and I'm saying just use 3 to make it simple. So the area of the circle is pi r squared. So it's r is 3. So it's 3 times 3. And then I'm using pi as 3 instead of 3.14, just to make it easy to do the math. And then 4 is the height. So 3 times 3 is 9. I mean, yeah, 9 times 3 is 27 times 4 is 108. So that's pretty straightforward. If pi was 3.14, you just put 314 in the place of that. This, they gave us the radius, and this problem on the second row, they give you the diameter. So you have to make sure that you put the formula, volume of this cylinder equals pi r squared times the length. And then make sure you substitute the radius and not the diameter. Don't just put 9 in there, 9 squared, but cut it in half. So 9 over 2 squared or 4.5 squared. Yeah, that's an easy mistake to make. So with diameter and radius, they use, for different formulas, they'll use one or the other, but they may only give you the opposite one in the information you get. So yeah, got to make sure you're dealing with the right one. So let's see, what's this? This is, oh, that's all they have for volume, 1 page, huh? Okay. So there's a couple more things to learn about volume. And Monica,
Yeah,
can you erase this?
yes.
And I'm going to give you some more formulas. Would you mind writing them down for me?
Sure.
So volume comes in cubic numbers, right? 3 dimensions. Cubic comes from cube. So, but we measure things in different units. So we have, so in the United States, we don't have metric. So we have inches and feet and yards are our typical length measurements. I mean, miles, of course, but we're just talking about construction material. So we could find a volume in inches, like this problem here, number 4, solve. A concrete brick measures 8 inches by 3 inches by 2 inches. What is the volume? So we could just multiply those all together because the volume of a rectangular is length times width times depth. So it's 8 times 3 is 24 times 2 is 48. So that's 48 what? What unit shall we call it?
Inches.
Well, it's a volume. So 48 cubic inches. Yeah, cubic inches, just like we called an area square inches. So when we find a volume, we have to make sure we have an inch by an inch by inch, which is a cubic inch. So this would be 48 cubic inches. But say we wanted to change that into feet, cubic feet. So
Divide by 12.
no. Nor is it divided by 144. So this is worth knowing. So put Monica,
Mhm.
do you think it would be possible to draw a cube looking at diagonally?
Sure, I
That's
could
really
try.
asking a
Yes.
lot. You're gonna
So-
try it, huh?
I'll try.
Okay.
A square at the
You're
front,
my hero.
right?
You're my hero. Yeah.
Okay, that's a square right there. And then a line
You want to go out that way and yeah.
out and out
Yeah.
here.
So it's those three. Yeah. Wow. Look at that.
And then here, straight as I can get. How far do I go? Same?
Yeah. Same. And then you
Okay,
can connect those.
here.
We don't care if it's perfect because it's
It's not
pretty darn
really
good
that
right
great,
now.
but
Yeah, that's fine.
Alright.
And then go down this way. You go up this way, I guess, first. You can go past and always erase it, I suppose, huh? That's fine if there's a gap or it's too long, and then go down this way.
That's pretty good.
Wow,
sorry,
let's give her a hand.
I wish I was like a graphic designer. I'm just an English teacher. I'm not
Wow,
qualified for this.
maybe you ought to add math onto your repertoire, you know? Wow, that's spectacular. I love it. Okay, so say we have cubic you wouldn't want to draw oh, can you draw another cube like that?
Same, two of them?
Yeah, yeah,
Okay.
yeah.
Above it or below? Where do you want
Either
to put
way,
it?
either place,
Okay.
whatever is easy.
All right, I'm gonna put it down here. Same.
I was going to have you,
square.
we're going to put numbers on it, and then rather than erase the numbers, it'd probably be wiser to leave them up. So let's do 2 cubes.
Okay.
So if you guys are ever going to be teachers or be managers in in an office, make sure you learn from Monica about this. Make sure you model yourself on her, because knowing how to do all these little things is really important. And you may be asking why I don't learn how to do them, but that's a whole nother story. Okay. Okay. Oh, beautiful.
Oh, wait, I went the wrong way. Sorry.
She's putting a handle on it. It's a cute
Thank you.
pot. Ah, beautiful.
All
Okay.
right,
Now,
1 second.
on this one, you ready?
Mhm.
Put 12 right here. And put 12 right here. And put 12 out here.
Mhm.
Okay, and then here put 3, same thing, 3, 3, and 3.
Mhm.
Okay, so So this is a cube with 12 inches on a side, right? So it's a cubic foot.
Mhm.
And what we want, but a cubic foot is what we call it. Let's see. No, it's a cubic foot. And if we want to know how many cubic inches is in a cubic foot, what do we have to do?
Square it or to the power 3.
Convert it.
Yeah, you can do, if you can, I don't know, if you have a calculator that does cube roots, you could do it. But how do we do a root by hand? Like a square root is a number by itself, right?
Yeah.
Well, 12 squared would be 12 times 12 or 144. If we want to cube it, then we have to multiply it again by 12. So 3 times by 12. So 144 by 12 is what? Anybody got a calculator?
1,728.
Thank you. So let's write that up here. Monica, 1 foot equals 728 cubic CU period IN period.
Okay, sorry, 1 foot equals, what did you say?
One cubic foot. So
Oh.
put 1 and then just put CU period for cubic and an FT period. And that's going to be equal to 1728 cubic inches. So just up there somewhere. Oh, beautiful. And then down below, write 1 cubic yard with YD. The next right in here
Mhm.
equals 27 cubic inches. No, cubic feet, sorry. 27 cubic feet. Okay, beautiful. So a cubic foot is just, you know, a cube 12, 1 foot on a side. But if we want to know how many inches are in that, then we have to convert each of these 1 feet on each side to 12 inches and then multiply those out. So 12 times 12 times 12 is 728. So there's 728 cubic inches in 1 cubic foot. And I can never remember this number, 1728. There's no historical date that's significant. There's nothing I can match that to. So I forget it every year. I teach this once a year, I forget this. But all I have to do is multiply 12 times 12 times 12. And I know 12 times 12 is 144 because I've been a carpenter all my life. And then I just multiply 144 by 12 real quick and I have that. So sometimes in place of memorizing things, you can try to remember how you arrived at them. And then that'll save you a little bit of space in your brain, maybe. So when we get to a cubic yard, it's 3 feet on a side because it's yards 3 feet. And so a cubic yard has 3 times 3, which is 9 times 3, which is 27. So a cubic yard has 27 cubic feet in it. So
Mhm.
we were here, we got what, 48 cubic inches, right? Anybody?
Where were we?
On this
What
number
was the question?
4, on number 4 here. Oh, you know what? I need to get back to my
48.
purple pointer. So
I'm
we-
sorry.
So we did this problem before, this brick, and we found the volume was 8 times 3 times 2, or 48,
Mhm.
and that was cubic inches. So what if I said, and how many cubic feet might that be? So you would put 48 over 1728. So it's not even going to be a whole cubic foot, it's going to be a fraction of a cubic foot. So leave these for right now. And we'll get back to them when we do, I've got some problems. But does everybody see how, for instance,
Yeah.
hello, everybody okay out there? So when you figure concrete, we're gonna do a problem or two of these in a bit. You would figure it in feet, cubic feet, right?
Mhm.
And then the truck, the concrete truck, you know, the one where it's got the spinning cylinder on the back. Those
Yep.
only deliver cubic yards. They only measure by yards because you're pouring so much concrete. If it's less than a yard, it might be easier just to do it by hand, although it's borderline. But they'll deliver less than a yard, but they'll charge you a special fee for under an under amount. So you have to know how to convert. If you add up all your concrete and you get cubic feet, because you're measuring feet lengths of a building, you never measure in yards, then you'll get so many cubic feet, and then you're going to divide that by 27. Say you get 270 cubic feet. You divide that by 27, you get 10 cubic yards. And you call up the concrete company and say, send me out 10 cubic yards. They just say yards, 10 yards. So you do need to know how to convert these back and forth. Okay, this number 5, a cylindrical mailing tube. You know what those mailing tubes look like? Has a diameter of 4 inches and a length of 36 inches. What is the volume of the tube? So somebody do this problem. So here's the formula for cylinder. So write this down. Volume equals pi r squared h, or area times h, either way. That's what you're going to use for this. Does anybody want to try it?
.14 times 6
Yeah.
times 5, which is the height.
Huh? Times.
94.2.
No, but have you put the diameter in there yet, or the radius?
Yeah, the diameter is 12, the radius would be 6.
Yeah, so r squared would be 36.
Mhm.
So it's 36 times 3.14 times 5. Is that what you did?
Mhm.
And you got 100 and, no. What'd you get?
R squared.
500 and something?
Mm-hmm. 36 times 5, 565.2.
Yeah. That sounds right. Okay, so what do we have? We had V equals pi r squared times height, right? And pi was 3.14. and R. So one thing you can do when you multiply in algebra is you can put parentheses around something if it's another operation. So R squared would be, the diameter was 12 feet, so the radius is 6 feet. So it'd be 6 times 6 times the height, which was what, 5? Make sure they're all feet. Yeah, okay. So that's what Monica did, and you got what, Monica? 400.
525.2.
Oh, 520. And he does a
Isn't it
total save.
565.2?
560, yeah, 565.2. Thanks, Jasmine.
Where's the pencil? Is there a? Okay, let's try it again. 562.
565.2.
And what is the unit for that?
Cubic feet.
Yes, cubic feet. Because this was feet times itself. And then this is feet. So it's cubic feet. So does everybody see that?
Mhm.
Yep.
Okay, now,
Yes.
if we wanted to do yards from that, how would we figure out cubic yards?
Divide by 27,
Yeah,
because 1 cubic yard equals 27 cubic feet.
right. So that's 27 cubic feet per yard, and that's cubic feet. So when you divide that, it'll be cubic yards, whatever that is. That's like 20 something yards. Okay, well, that's not so hard, right? That's the hardest circular geometrical problem we'll have today. And that's doable. So look at this. So here's what I like to do. This is just a process tip. And I don't know how Monica did it. She did it right. So however she does it is good. But I write the whole thing out. And say there were say there were 5 of these water tanks in a row, and they wanted you to know how much the total volume was. I would put times 5. I would put 5 at the beginning or somewhere. So that's the total problem. So that volume will include the number of tanks. So I make sure I have everything the question's asking for in that initial formula. I just set up the formula. So that's the volume for 1 tank. And then if there were 5, I'd say 5 times that. Then I would, pi you can plug in, height you can plug in, radius squared, you have to do a process. Hold on. So so you can put parentheses around something, and it just means that you do the inside process first, and then you keep multiplying. So squaring R is same as R times R. So I did R times R, and then I come up with that number, and then I stick it in and then I multiply these 3 together. You see that? So you can separate out some of the numbers if you have to do a little work, preparatory work. So that's helpful to be able to do that. but writing everything in the beginning, I have students at night. Yeah, how can I make you go to China and stay there, huh? Or wherever you're from. Okay. Pardon me. So, yeah, so it's really important. I have students that will get the one right and they'll forget it was 5 tanks. And so the number will be 5, be too small and they'll get it wrong. So come on. Is there an erase all button? There should be.
Yeah, so you click on the little garbage can. It'll say clear all my drawings.
Oh, yeah, but that'll clear these two though, right?
Or clear my drawings rather than clear all drawings. Clear my drawings.
Ah, great, great.
Ah,
What would I do without you,
Zoom.
Monica?
This is like a Zoom class. You learning about Zoom today, everyone?
Well, it's good to know. It's totally good to know. You may be you may get an office job at some point in your life, and they require you to set up Zoom meetings and manage them. So every bit helps. For me, it's a waste of time because I'm never going to do this stuff again, unless we have another pandemic. But if I'm, then I think it's I won't say it. We don't want to even think about another pandemic.
Well, I think that it has crossover value of knowing how to do various things. Like me, like doodling opened up the door to me being able to contribute to what you're sharing.
Yeah.
And Monica had a much more adept knowledge of that than I did.
Yeah. No, but it's good though. And it is a team effort. I mean, I want it to be a team effort, Also, it keeps us from getting too bored if we're all trying to figure something out, like how to run Zoom. So let's look at some of these. I've got some, I circled some on my own sheet. Well, one's ridiculous, right? We know how to do that. Find the area of a carpet that measures 20 by 18. So, and you don't have to do long math or know your tables for these kind of problems. You can just use your calculator and get the answer. Let's see, I have number 6. Oh yeah, so let's see how many people can find the area of a circle with radius 3 inches, and just use 3 for pi, okay? So all of you try to find the area of a circle with the 3-inch radius using 3 as pi. What do we get?
What's the equation?
Pi r squared. Pi is
Pi r
3.
squared. And
Pi is 3. R is 3. Hey, Monica.
27?
27, yeah. Monica.
Yeah.
Is there a way they can respond with an answer? All of them? Can they do it in the chat?
Yeah, you can put it in the chat. I mean, you can say like, everybody put your answer in the chat. And not everybody, I don't think not everybody can unmute at the same time and give you the answer because everybody's going to get it at different times. But yeah, you could say, put your Put your answer in the chat box when you have it.
Can we make them all do it?
Yeah, practice. Why not?
Okay, everybody put the answer to number 6, which we just gave away. So if you're half awake, you don't have much work. In the chat, next year, does their name automatically go in there?
Yeah. Wait, we can't see your screen. What are the problems we're doing?
Well,
Can
you
you
can't
share,
see the
can you share
screen.
screen?
Yeah,
Mhm.
no, we're
You're-
looking at you.
We were just
Guys.
listening to you dictate the problem. We don't know.
You guys. Sorry. I'll apologize, but then you need to apologize too for letting me go this long.
Okay.
Okay.
Now, sorry, you got to make it a little bit bigger, zoom in a little bit. Please. Thank you.
Number 6, find the area of a circle with a radius of 3 feet.
You said it was pi r square, right? The
No.
equation?
Yeah, the equation's volume equals pi r squared. No, yeah, no, area equals pi r squared. And pi is 3, make pi equal to 3 in this case.
Put your answer in the chat when you have it.
And do it in a hurry. Because we're moving on. So can you see that? I can't get the chat when I'm on my sharing my screen. Can I? I don't think so. Oh, pause share. I never tried that. That's interesting. So are we, Monica, can you check the chat?
Yeah, most people got it.
Okay.
27 or 27 feet.
Yeah,
Is that
great.
what everybody got? Yeah.
Okay, let's go to number 11 in front of you. You can all see this. Find the circumference of a circle with a 12-foot radius. So that formula is pi
44 times.
pi d or 2 pi r. Let's say 2 pi r. Circumference equals 2 pi r. And use 3 for pi. This way you don't even need a calculator.
2 pi.
2 pi r, yeah, or pi d, either one, but since they gave us the radius. Yeah, don't give out this answer out loud. Let people try it first. How we doing? Anybody got it? Monica, how's it filling up?
We got one answer. We need more answers than one. Somebody else.
Oh,
Somebody
God.
else give it a try.
Number 11, find the circumference of a circle with 12-foot radius. Formula is two pi r. And pi is going to be 3. So it's 2.
Why is it 2?
Because it's pi d is the formula, but radius is half a d. So 2 r's is d. So pi d is the other formula. It just depends on what they give you. If they, if they gave you either one, you could always find the. You could always find the. If they give you the diameter, you could find the radius and vice versa. But they give you two formulas, so you don't even have to do that. You just, if they give you radius, you plug in this formula. If they give you the information of diameter, you plug in this formula. So let's say 3 for pi and 12. So this is going to be, so this is how you can tell. Diameters in feet, radius is in feet. Pi doesn't have a unit, 2 doesn't have a unit. So the answer is going to be what? 72 feet.
Luis, you got it right.
Yeah.
I was way out of the ballpark. But that was because, well, I forgot to take into account the radius and diameter factors.
Yeah. I like to just memorize pi d because it's so simple. And then if they give radius, I just double it. But so how's it going?
I think it's like thinking about like when I was in high school. It's easier when you have like your phone or like the internet at hand because you can look up the formula whenever you forget. Because I remember like in high school you had to memorize all these formulas like pi r squared, and I
Right.
couldn't remember them. So that's part of what made it difficult is like memorizing all the formulas. You don't really have to do that anymore. So you can just look it up if you need to, right? That's pretty easy.
Right. And these formulas, you just have to go up a couple of sheets and they're already on there. So yeah, no, it's great. I never memorize any of that stuff anymore. Some stuff you can't unmemorize because it's been drilled into you for half your life, so you never forget it. But so we're going to go on. The rest of you keep finishing that problem. So Francisco talked about a Pythagorean theorem. Oh, this is the good part, connecting the dots. Okay. So if we want to say a triangle's a right triangle, or it has a right angle here or a 90-degree angle, we put a little box in it. That's the symbol for being a right angle. Ah. So time's up for that. So back here, how do you spell his name? So we were talking about a thing called Pythagorean theorem, right? Named after a guy named Pythagoras. And he realized that if you took the square of this side, so you squared this length here, so it's this length times this length, and you squared the bottom and you squared the side, that if you add this square area and this square area, it turns out to be the same as this square area. So how the heck do you think anybody figured this out? I don't know. So we have a formula, C squared, which is this area. So C is usually the hypotenuse, the long part of a triangle is called C, and then it doesn't matter which side are A and B. So C squared, that's this big square, equals A squared.
Hey, Patrick, can you do a new share? We're still looking at, oh, never mind, I see it here.
Are you sure?
Sorry, go ahead. No, I got it. Yeah, thank you. I can see it now.
Okay. So this is A squared is A times itself. So it's the same as an area of A. And this, probably the Egyptians figured this out when they were dividing their fields up. And then they figured out if you square this side or multiply it by itself, you get this, visually you get an area. These two areas added together equals this area. Of any triangle that has a right angle in it, this is true. So that's a very useful formula. So if we have, so this problem here is find the length, number 15 here is find the length of the hypotenuse of a triangle with sides 1 and 2. So say this was 1 and this was 2. And they want us to find this one here, X, this long one. So we can use this formula here. We can say X squared. We're looking for this C, so we'll call it an X, equals A, which is 1. So what's 1 squared is 1. 1 times 1 is 1. And then B squared, so B is 2, so 2 times 2 is 4. So that side, so the only thing we can do to find X is to take the square root of both sides. Remember, you can do the same as long as you do it to both sides. So that's square root of 5, whatever that is. Now, I explained to you about calculators that the tax calculators don't have the square root function on them. But Francisco, do you have a calculator that has the square root function?
Francisco, you're muted. Can you repeat what you said?
I'm sorry. Yeah, no, my cell phone, it's got like just regular text setting, and then it's got the scientific.
Does
So
it
the
have
cell phones are,
does it have a square root function?
yeah, X2 and the square root.
Okay, so
Nine.
take the square root of 5 for me.
All right.
if you would.
2.5.
And 2.5. You don't really mean that.
No,
Oh,
that,
look, it erased all my drawings. Because you guys weren't answering, you made me erase my drawings.
I'm not sure how to enter it in.
What'd you get for square root of 5?
2.2360 run on.
Yeah, 2.23, 2.24 is close enough. So that's what that hypotenuse, that's the answer to that number 15. So is anybody paying attention to this?
Yeah.
No, you guys. One more thing and then we're gonna break.
It's pretty hard.
Yeah, okay. So yeah, I know it involves algebra and square root, so I understand that. But what's interesting is in construction, we often want to make, we say we have a first wall running this way, and then we want to put a second wall at right angles because houses are often squared, rectangles or squares. And so we have to know how to make a line going off this line. So there's that Pythagorean theorem, there's only 2 triangles in the whole universe that have come out with whole numbers for sides, believe it or not. It's pretty amazing, huh? Say yes, because you know it is.
Absolutely.
Yeah.
Wow.
Well, you don't need to go that far. Let's see, 25 and 140, yeah. These are the 2, 5, 12, 13, and a 3, 4, 5 right triangle. We're talking about right triangles. Every other triangle has a combination of whole numbers, 1 or 2, plus a decimal number, and it's a repeating decimal. They could have 2 repeating decimals and a whole number, or 2 whole numbers and a repeating decimal, but only these 2 and all of infinity have, at least in this geometry system, have whole numbers for all 3. So that's very useful because you don't want to deal with decimals when you're building. So if you want to make this wall perpendicular to this wall, you do a 3, 4, 5 triangle. So you go over here 4 feet, make a mark, and then you take your tape measure from this point and you make an arc at 3 feet. You just make an arc on the dirt or on the plywood, whatever. And then you take your tape measure and put it on here and do an arc for 5 feet. And where these 2 arcs meet, that's where the straight line comes. And you can do multiples. So you can do 2 times each of these. So you can do a 6, 8, 10 triangle or a 30-foot, 40-foot, 50-foot triangle. And as long as you keep these 2 sides, this at 3 and 4 or multiples of 3 and 4, then this will always be 5 or multiple of 5. Pretty handy, huh? And they don't use this one because it's long and thin. And so you need a lot of room and a little room this way, and it's more awkward. But this is kind of a fat, easy to work with triangle. So in building, when they say use your 3, 4, 5 method, they mean this right here. So even something as abstract as finding hypotenuse with a Pythagorean theorem has an application in building. Now you don't need to use the theorem because they've already, if you did the Pythagorean theorem, the sum of these 2 squares would equal this. So it's already done. So all you have to remember is 3, 4, 5, and 5 is always the longest one. And 3 can be, you can go either way. You could go 4 up and 3 this way. Because you're just looking for this intersection to be able to draw a straight line for that wall that's perpendicular to this bottom line. Does anybody get that?
Yeah.
Wait,
Yep.
so what's the bottom one? What is it? 5, 12, 13? Is that what it says?
Yeah, but we don't use that. That's just the only other one that's got whole numbers for sides.
So this is not as common in like construction
Well,
to use
it's
the bottom
long and
one.
thin, so it's not useful for building. Building, you want something square because you don't want to go, you know, a football field this way just to go up a little bit this way.
Mhm.
So they tend to use this one. But it's really
Mhm.
useful to know if ever you want to get a right angle and you don't, you know, you can't use a protractor because these are in feet, right? If it was just on your, if it's just on your paper, you could use a little right triangle and copy that, but this is for in the building in the real world. So, Monica, what do you think you would be talking about in a breakout group?
Maybe doing some practice if anybody wants to do practice, like on, I feel like the vocabulary is pretty similar, translating wise, but maybe doing some practice on some of the ones that were
Okay.
difficult.
Okay, then let me
I
do
don't
a
Is that useful, or do you want to do practice together?
well,
or?
you know, we can do more practice tomorrow, a little bit in the morning, right?
Yeah,
You know, and kind of on everything, just to sort of revisit it just briefly. So let me
Yeah.
show you one more concept that's kind of interesting.
sounds
And then we'll break into groups. So remember I was telling you that lines, the first thing in geometry, according to Euclid anyway, were lines and then areas and volumes. Well, here's something that's interesting for lines. And this in building, this could happen. You'll get this often. So you have one line crossing 2 other parallel lines. These 2 lines are parallel. And you want to know what angles. So this angle's X, and the angle across from where 2 lines cross is always the same angle. Now, that's intuitively obvious, but I don't know if everybody knows that. And then say this one's, we'll call this one Y. And then across from that, it's the same too, right? Now, what's interesting is it's the same down here. If these 2 lines are parallel and they're both cut by this one line, then these angles repeat down here. So, I mean, is that really obvious to everybody that angles across from each other where lines cross are the same angle?
I wouldn't say that it's obvious, but it makes sense.
Okay. Yeah, well, okay, that's a good way to put it, exactly.
But only if those other lines are parallel. If they're not, we can't make that assumption.
Right, right. But a lot of times in building this situation, I can't think of one offhand, but this situation will come in and you don't have to keep thinking about it. Once you get one angle, all the rest you've got. And then I'm going to show you why that is. So this is a straight line. Just fantasize that's a straight line, okay? So say
That's a
this
180,
is,
right?
yeah, this is an angle. That's the vortex of the angle right there. So it's, you know, instead of going like this, each side's going straight out. So that forms a straight line. So that's 180-degree angle, yes. It's half a circle, 180 degrees. So then if this number is X, this angle in here is X, then this one will be 180 minus X, right?
Well, doesn't it give us at least one of the numbers?
No, I'm just saying if you add these 2 angles together, 180 minus X and X, you get 180.
Yeah.
But the reason this is useful is because if you do have this angle, like say this is 20 degrees, then what's this angle going to be?
160.
160, yeah. So they call this a supplement. These angles supplement each other. So this is a supplementary angle. So if someone says, what's the supplement of 20 degrees? You would say, what's 180 minus 20 is 160. If they said, what's the supplement of 90 degrees? It would be what?
90?
Yeah, it'd be 90. So you just take 180 minus whatever they give you. And we have some problems with that, some problems to work on that, not issues with it. And then there's one other one related, and that's at a right angle. You have a number, an angle, and then you have a 90 minus that angle. Same idea. That's a 90 degree minus x. So that if you add these two together, 90 minus x plus x, you get 90, and that's a right angle. So they call that a complementary angle. These are just names they came up with to distinguish them. So supplements and complements. So find the supplementary angle of 27 degrees. So how would you find that?
You'd subtract that from the 180?
Yeah. And if it was complement, you'd subtract that from,
The 90?
yeah. So that's all that is. And that's useful. So just put that in the back of your mind. So let's break into groups. And we can do whatever we want. So breakout rooms, assign manually, create. So Monica Campbell is the first in her group. And then we would have Esperanza
Yes, please.
and Gerardo.
Sure.
Israel, is it Israel good? Yes, no, maybe?
Yeah, sure.
Yeah.
Sure.
Anybody else?
What kind of answer is sure? Is that yes
Sure.
or whatever?
Like, sure, why not?
Yeah, whatever.
You know,
Sure,
I've
why
had
not?
other people tell me, I don't know what you mean by sure. I'm like, it's like, yes.
Well,
it's-
sure also as the way you say it. Like Monica goes, sure. And then you know it's like whatever. But if someone goes, can I do that? And you go, sure. So, okay. Anybody else? Going. I tell you, she's a lot
Anyone
cuter
else?
than I am.
It's a lot more fun in our group.
I can go with her too.
Jasmine.
She goes, God, I've had enough of this guy. Give me. Okay. Is that good?
Yeah.
Okay. Gone. Okay. I don't have to, do I have to open the rooms?
Yeah,
I keep,
thank you.
closed rooms means like you've assigned everybody, now close the door and go to your room, right?
No, not in this case.
Not in this case, I know. God. You got to have like two minds to do anything in this world, The reasonable mind and then the mind someone else creates for you. All right. So what do you guys want to do? So was any of that hard? Let's ask that question. And then we can just do a few problems and that's all we have to, we'll just mess around. That easy, huh?
Yeah, some were more complex than others.
So is anybody confused about any of them? Yeah, hard and easy doesn't matter because as long as you know how to do it, you know, it just takes longer.
It was just remembering the equations or, yeah, just getting the equations right more than
Yeah.
anything.
Yeah, I understand that. Let me get I don't need my view. Okay. Yeah, and on that, those worksheets, the equations are all on that first. I think, oh yeah, oh yeah. That was my mistake. You couldn't go back on the worksheet, only I could because it was on my thing, right?
Yeah.
So that's why you guys, that's okay.
Notes.
That's why you weren't going back and getting the formulas. So I apologize for that. One thing that I should have told you to do, and we can do it tomorrow and the rest of today, is to go to the file in your Canvas. You can do those while you're looking at the screen, right?
Not really, because Zoom ends up taking like the whole screen, especially if your screen's sharing.
Yeah, okay. Well, then that wouldn't have helped. Yeah, well, so that's fine. If you ask me for the formulas, like I've been doing, I'll just give them. But if you're looking at this for yourself, between now and Friday, if you want to, get those formulas and write them down or just review them or do some of the problems, just go to your file. And they're under, hold on. They're under geometry handouts and find the area of a circle is the other one. I didn't give it another name. So we've got so many files in there from this class that you kind of have to know what you're looking for. So tomorrow we'll just do a few, maybe we'll try to, well, the Pythagorean theorem, Monica said that was hard. I think she was speaking for some of you, or maybe it was hard for her too.
Well, I mean, if it's not something you're putting into use on a regular basis,
Yeah,
like I was, but I knew I had some roots in understanding it previously, so I knew I could understand it again.
yeah.
It was just figuring out the equation and why.
So in the Pythagorean theorem, it's really different than all the rest we've done today because it's really algebra, even though it's about a geometric shape triangle. You're squaring and taking the square root, right? So that's not geometry. So I think everybody gets squaring something, right? Don't you think so, Francisco? Like we've mentioned several times, like multiplying by itself.
I think a larger majority of who we have here in this breakout would probably
Know that.
Yeah.
And then the other one was taking the square root. That's kind of new. So maybe I'll go over that. But unless you have a calculator, does everybody here that's in this breakout room have a calculator with them today? Or who doesn't have a calculator?
I think most of us have a calculator. It's just like I didn't know how to enter in how to find the square root of something till I started messing around and entering it
On my
different ways.
what do you call this? A hand calculator as opposed to a cell phone. On my hand calculator, I just push the number and then I push the square root sign after that, and it gives me an answer. Is that how your phone works?
No, actually, I think it was the square root first and then the number.
Oh, interesting. Okay. Yeah, that's the thing about calculators. They're not uniform.
For sure.
So you can fool with that. If it won't work one way, it'll work. It's probably working the other way. So you don't need square roots so much anymore in the world and in life, except for Pythagorean theorem.
And I haven't used that in my life yet.
Yeah. So the 345 uses it, but it's already done for you. So you don't even need it there. But sometimes you might want to find a side to a triangle when you're, it's possible you could be measuring something and you couldn't reach a tape measure to get across the top of a triangle, but you could measure the sides and the bottom easily. So that would be an example when you might use it. So here's one. Speaking of Pythagorean theorem, and let's see. Okay. Okay, can you all see me? See the plane figure page?
It's kind of small. Can you zoom in?
Yeah, it's okay. That's okay. I'm going to draw on it.
All right.
Now, how about the drawing? Can you see that okay?
Yeah.
Do they have let's see. They do. Okay, great. Yeah, I've been looking for that straight line. Okay. Oh, that's cool, isn't it?
It's interesting, like the ways to learn how to do stuff. Because
Yeah. Well, there's one of the biggest problems is having uniform standards in the world, so people don't have to reinvent the wheel every hour of their day. And computers have some standards, but they're not standard enough. But people that work a lot with young people that work a lot with computers, they've worked enough that they see a bunch of the templates, even if they're not the same, they're similar enough that they can work back and forth. So, like this, when you press the annotate on the Zoom tool bar, and then you press the draw, they know that like there's a curved line, there's a straight line, a rectangle. And it's easy to figure out. But if a person didn't do a lot of that, they would be kind of lost. I'm kind of in between.
I don't know how Monica did it on her computer, because I had to log on my not my laptop, on my tablet, and use the stylus on my tablet to be able to do the drawing.
Yeah, I don't know how she did the drawing and then did it on her own and then published it.
Right? That's insane.
I know. I don't. Maybe it's in that toolbar, that annotate toolbar. I'll have to play with it. I haven't had a need for it, so I haven't looked at it. So I'll play for it now. But anyway, so you see that triangle, right?
Yeah.
And there's another thing that I'm going to probably tell tomorrow, and that is A triangle has the sum of the angles in a triangle is always the same number of degrees. And does anybody know what that is?
180?
Yes. Bingo. Oop, I'm still in the.
In my back.
Ah. So 180 degrees, I'm not going to erase that now. I have to. So if this is 90 and this is 45, what's that upper angle?
45?
Yes. So in drafting, they make a little plastic triangle in this shape because 45-degree angles are not uncommon in architectural design. You know, you have a porch or side of a house that may cut back at a 45-degree angle. They do all angles, but 45 is more common. So they make a little, you've seen a little plastic triangle. It's got a hole in it there. But this is a useful triangle in building because you need 45-degree, but also in terms of the lengths of the side, it's interesting. So if, say you take 1 unit for the side. So Pythagorean theorem says that this squared plus this squared equals this squared. So 1 squared is 1 plus 1 squared is 1. So that's 2. So the square root of 2 is this side. And it turns out that the square root of 2 is 1.41, which you could find on your calculator. It goes on, but we'll take 1.414. So this is close. What's the close? What's the symbol for close or approximately? The sign squiggle?
I have no idea.
What? You don't, that's
I don't
close
know.
enough. So 1.414, 1.5 is just a little bit above this.
It
So
looks like, and yeah.
yeah, so a rough calculation of a 45-degree right triangle would be, if the sides are 1, this would be 1.5. So if you have a porch and this side is 10 feet, about how long will this side be? Are you guys back? Is everybody back?
Hi, yeah, we're back.
Okay. Can you see this, my screen?
Yeah, yeah,
Oh, okay.
Yeah, we can see.
Okay, so we were just talking about, and I'll probably go over this briefly tomorrow morning. The sum of the angles in a triangle is also 180 degrees. In other words, if you add up all 3 angles in a triangle, it comes to 180. And that's useful to know. So this is a right triangle, which means
So would-
one of them is 90. So if you know the other one, then this is the complement of it. So this happens to be the complements are the same, works out. If this is 45, this will also be 45. So we call that an isosceles because 2 sides are even, but you don't need to know that. But this is a useful one in building and design because if you do the Pythagorean theorem where you square this and take the square root, you get 1.4 or 1, which is approximates 1.5, 1.5. So if this is 1, this will be about 1.5. And that's kind of useful in building because say you have a deck that's 10 foot long this way. And so it has to be 10 foot long this way. And you want to know, well, how long a board will I need for this? You just say 1.5 10. So this is going to be 15. And 1.5 is actually a little bigger than 1.4. So 15 will give you a little extra. which you'll need. So a lot of times in building to find, if you have a 45-degree angle somewhere and you know one of the sides, you can find that hypotenuse pretty roughly by just 1.5 times. Does that make sense?
Yeah.
Yep.
So there's another triangle which we won't do, but they also use it in drafting, and it's a 60-30. So this is 90 and this is 60. When on a floor plan, when you show the doors swinging out, they swing out this degree here. Is it this one or this one? But this has interesting properties too. For instance, if this is 1, this is 2, and this is square root of 3. So if you know it's 60 degree, then the hypotenuse is twice the smaller side. So sometimes when you're on a plan and you're trying to figure out the length of lumber and they don't actually give it to you, you can use these relationships to figure it out. So hello. So we're just about done for today. And tomorrow you have Rodney and more electrical. And then you'll have me again Wednesday. And we'll just talk about a few of these things that we did toward the end, and we'll do a few problems for probably half. I haven't figured out what we're going to do, but we could do that right now. And then maybe the second half we'll talk about, we'll just see how many people we can get to participate, about feedback to the program and what you learned and what was useful to you, just so it kind of summarizes that 6 weeks. Is that how long we've been together? Oh my God. 6 intense weeks, huh?
7 weeks. This is the 7th week.
Oh, 7 weeks, yeah. It's even worse. It seemed better. So Carla, not Carla. Carla's here. Hi, Carla. Monica.
Yeah.
When you did those 2 circles,
Yeah.
and they didn't appear till you finished drawing them, was that all done through the annotate toolbar?
Yeah. Yeah.
Oh, get out of here. Really?
Yeah. Yes.
How did you do that?
How did you hide it until you wanted to present it? What icon did you hit?
I don't click enter until I'm done drawing it. So in order to, I want to make sure that it's right. So I pulled it out, and then if I don't like it, I can erase it and go back. And then when I click enter or I commit to it, then it shows up on everybody else's screen.
But you said commit earlier, and I thought, well, I know I didn't see a commit, but it's enter. You enter.
No, I think I just clicked enter maybe, or maybe it was the space bar enter, one of those two.
See what I was telling you, Francisco? Who would know to go
How
to
did you access
who
it?
would know
How
to
was
go
I
to the
able to do
space
it?
bar to do that? That's insane.
But I think it takes, you know what, Zoom takes a lot of practice. Zoom has all these tricks on it,
Yeah.
I think, that you have
Yeah.
to learn. And when you take these like Zoom courses and like, learning more tips and tricks for Zoom, they
Yeah.
teach you all this stuff,
Yeah. And I was telling Francisco that computers in general have kind of a similar vocabulary, enter and all that. And so there's an overall kind of knowledge that people who fool with computers have, but then they separate into, like Zoom has this whole different thing than Google,
different.
And
Well, also like for me, like I've always my whole life, like since I started using computers, I've always been on a PC. So if somebody puts a Mac in front of me,
yeah,
I don't even know I don't even know how to turn it on. Like, I don't even know what to do with it. Like,
They're
I'm
so
just like,
different,
don't
and
just throw that out the window.
and Mac is so unintuitive. My wife has a Mac, and I'll just get on and I go, I think
Like, I think I tried to do, I went to my mom's house and I like tried to use her computer for like I think my other like laptop from school like crashed. And I was like, Mom, let me use your MacBook. And I was like, oh, sorry, never mind. I can't do class on this.
I know. They're really, once you learn it, people swear by them, and they're for certain things, they're really good, but for certain things, they're not good. PCs are better. I'm totally convinced. But Apple people are so cultish, that once they're on an Apple, it's like, oh, I wouldn't touch anything else.
It's like a religion.
Yeah. they're great products. I mean, those guys are
Yeah.
geniuses to figure those out. But I think PCs are a little more intuitive and
They're
simpler.
just user friendly, yeah.
Yeah.
They're like,
Yeah, whenever I do, sometimes I'll do a project, I'll do a program, what do you call it? I'll go somewhere and do a program, learning stuff. And sometimes we'll have to use PCs and do it. And it's crazy. It's too much work. So yeah, and I wish they'd make things uniform too, but they don't. And talking about word problems and how it's real important, I was trying to clean my coffee maker last night, and it had this book, and it might be a French thing and they've translated, but they missed a lot in translation. And the instructions were insane. I was so angry. I don't know, does anybody else get angry when they're frustrated with bad instructions?
yeah, I think the problem is they're translated into another language by
Maybe.
a non-native speaker.
Maybe.
So
But it's really critical. But they don't even say, they leave off. They don't even add the few extra things you really need to know to like close a process. I wish we could take off a year and nobody could invent any new program or algorithm, period. And we just had to work on the ones we have for that whole year and get them perfect. Meet together, form little groups around the world and say, well, this is really silly, isn't it? And everyone goes, yeah, get rid of that, Not going to happen. No, okay. So, yeah. So tomorrow you have Rodney. Wednesday, I will see you, our last day. This is great. You guys are really great. You've gone this far. It's not easy. On either end of this, it isn't easy. So I congratulate everybody, and I'll congratulate you more tomorrow. But I will see you Wednesday, bright and early. Okay? Any questions or anything? Yeah, question, yes. Was there a question?
Thank you, Patrick. That was a good class. I think that was really informative. That was really challenging. I think that was harder for a lot of people than the algebra or than the fractions. But
I know. It's true. Geometry is kind of intuitive because you can see it. But I find that people are split. Some people think they're good in geometry, but actually the arithmetic's easier for them.
I think it's pushed more, maybe the arithmetic's pushed, like it's got this force on it first, and then the geometry, like I feel like in public school, like you cover it, but it's not like that strong push. So it's good to go over it like again. And I think that was really clear, and I learned a lot and refreshed a lot. So but it was difficult, I think.
I wonder if computer people deal with geometry, any phase of programming or that. Programming is pretty algebraic, but there's got to be somebody besides trade people, carpenters that use geometry. I can't believe that it's just plumbers would need, when you're doing volume, you've got tanks. A lot of plumbing involves tanks. So obviously electrical and plumbing would do it, but
Water treatment.
anything related. Yeah. And usually those jobs, they train you, the little bit that you need to know, they just train you right on the job. But I don't know. I think it's nice to know, even if you don't remember the formulas, because God knows we have a lot to remember. But if you know where to get them and you just get an idea of how things work, I think that's useful for people, but that could be just me. So let's go, and I'll see you in a few days. Bye, everybody.
Bye,
Good session
guys.
today.
Thank you.
Yeah.
All right,
See you guys.
class, guys.
All right.
Bye.
See you later.
Bye-bye.
See you later.